Okay, so this will be a presentation on the stuff I've been working on for the past few months. It's mostly related to conversation flows whenever you're talking to various things within the game. But let's go ahead and get started. So what's in the presentation? Well, to start with, we'll go over a demo of the different outputs from the stuff I've been working on. And then a large portion of this video will probably be more of a technical discussion. The primary point of this video is so that I don't just drop several months of work of PRs with no explanation, because that would be a bit difficult to review. But also, I kind of want to get everyone on the same page in terms of what's going on here. Yeah, to help with understanding the PR and to help with just understanding how this stuff works in general. So part of it is definitely documenting the research. So as opposed to writing out a lengthy document, which comes with the benefit of being easier to edit, but it's a lot easier or a lot harder to create. So anyway, we'll have this video. And I want to go ahead and apologize in advance because I think I might be kind of sick, but I don't want to delay recording this anymore. So I've already tried to record this in the previous slide over and over and over. Yeah, so I think I'll probably just keep going with it being a little scuffed. If you've seen any of my videos, you're used to long videos and rambling. So yeah, as much as I wanted to try to avoid that, we're probably going to end up with that again, just for the sake of actually making it through this, so that I can continue on and not get stuck on this for however many days until I feel better, because it'll probably be a lot of recording, and trying to do that on a weekday might be kind of difficult, and I don't really want to delay this by another week. So anyway, there's your introductory rambling, but we'll go ahead and continue. All right, so what's the motivation behind all of this work in the first place? So the main motivation is that now that we are going to have the random spawn feature starting in 1.3, the hints and stuff that are based on your starting position being outside of Link's house, where you have the Ordon hint sign and Link's house sign right next to you, that's no longer a guarantee. So treating those as info that you'll read at the start of a run every time isn't reliable. And so I wanted to try to move that information onto Midna, who you always have access to, basically, and who is there with you for like 99% of the game. The only time you don't have Midna is at the very start of the game if you're actually doing the prologue. But the prologue probably takes 10 to 15 minutes, maybe something like that. So it's the vast majority of the time you have Midna, and a lot of people will skip the prologue anyway. So, but yeah, if you were to randomly spawn somewhere, then we want you to have access to your required dungeons, as well as any starting hints, which might be more of a race thing. But okay, but if we're going to put this on Midna, then we need, currently if you go to the third option, like the talk to Midna, it's change time of day. So we want this info to be on Midna, but we still need it to where you can change time of day from Midna also. And while we're in here messing with stuff, we want to see if we can get it to where changing time of day is not locked behind Shadow Crystal, because that's an implementation detail rather than an intentional design decision. And if you've ever started a run without Shadow Crystal, as some people like to do sometimes, it kind of is annoying at the start of a run because you have to kind of rush Kakariko. But if you're not there when the time is correct, then you end up waiting like several minutes and stuff like that. So anyway, we want to see if we can try to correct for that. But okay, next slide. Okay, so let's get into the demo part of this. So the first thing I want to go over is the Midna changes. So when I pull up Midna, in this case I have transform into wolf warp, and then the bottom option is something else. And the text on this stuff's not finalized, but if we click on that one, then we get a different menu where we can change time of day, and we have access to hints. And we can press B to back out at any time on these. But let's check out hints first. And I have time of day at the top, because that's where you'll, like when you start the game, you'll read hints probably one time, but change time of day you'll do throughout the game, and so I wanted that to be in a more convenient position, so you can kind of just mash A. Because nowadays, or is that the right word? Currently, you go down here and you click it and it changes time of day. So the change there is you kind of mash A instead, but it's about the same. But okay, if we look at hints, then you'll notice Midna's talking through these, and like the text is blue instead of white as the default. It's because we're using the Midna sort of styling here. But yeah, so it says the number of required dungeons, and then it says what they are. And this could split across multiple text boxes if there were, you know, 8's the maximum. But if there were 8 required dungeons, then it could be multiple text boxes. And I have it split into 2 because the default Midna text is like that blue color, and then when you have the blue with these other things, it just makes it harder to read, I think. And then this is an example. This is probably more of a race hint distribution thing, but you can also put hints after the after that dungeon info, which is why they're called hints. It's just general hints. I mean, the required dungeons is also kind of a hint as to what you're supposed to be doing. So, but yeah, if you look at the Link's house sign, I still have this here because there's not really a reason to remove it. So if you were playing where you didn't skip the prologue, for example, you'd still be able to read this. Okay, let's look at change time of day. So the place I'm in currently, there's no like natural time flow, so it'll reload the room. So if I do that, then we can change time of day that way. So that's nice. Now if we are wolf, then the way this works is slightly different. And in fact, the menu is actually kind of different because you have transformed into human. But one thing, if you're familiar with change time of day, in the current implementation, I did find or figure out how to fix the thing where like if you change time of day, the it would like pop up this menu again as if you were talking to Midna, which was kind of not very desirable, so I found a fix for that. So if we did change time of day while talking to Midna as wolf, in a place where time doesn't flow, then if you look, it works more like how you would expect, where the menu doesn't pop up again. So like that. So anyway, I was happy to figure out how to fix that. So just like that. And then hints. Yeah, if we go here, I have it not on fast text or like instant text on purpose to show this. But if you watch Midna, like watch her mouth and the sound, then like that's working correctly as well, which is cool. Now if you use instant text, it's kind of iffy on when it works. And I think that's just because like when you're talking to Midna, yeah, so you saw there. if you like quickly end the text, it'll kind of just instantly cut off her voice, and that's a vanilla thing. But since instant text skips to the very end, it kind of can cut off her voice. So that's maybe there's a way to deal with that for instant text, but it's not super important. You'll probably only talk to her like that one time at the start. Okay, let's go over some change time of day edge cases. You'll see there's a extra sign here. That's just for demo purposes. I'll go over that later. But okay. So I have these post shadow crystal menus. I won't show these, the other menus, but if you, like before you have the shadow crystal, sometimes you'll have like at the very beginning of the game, or close to the beginning, when you have the ability to warp because you're in a twilight, but obviously you don't have shadow crystal yet, then it'll be like warp, talk to Midna as the menu, and then there's there's like different variations, but all of those have been updated to work, or updated to work correctly, yeah. But okay, here the time doesn't flow, so we'll just mash A through that. And you can see, all right, there we go. And if we were to go down here and mash A again, then, oh, nice, started raining. Okay, so that works as you would expect also. Now let's go over some edge cases. So essentially the way this new submenu works is that anytime the game would resolve to talking to Midna, it will instead show the menu. Now there's some checks, which maybe I'll go over that in a second, but so for example, I'm on land, right? So I have the ability to warp and transform into human, but if you recall, in the vanilla game, if I was like in water like this, and I press Z, then it just goes straight to talk to Midna. But we're essentially hooking into where we're talking to Midna with the new menu, and since there's no reason we can't change time of day or talk to her for info, then like while we're in water here, then we still get the menu. So like I can actually change time of day from water because it's less restrictive than like warping, for example, where you actually need to be on solid land without a slope and whatnot. And we can do the hints as well, which we've seen. And you can back out without doing anything. So yeah, I'll go over how menus work later. But one interesting thing, it looks like there's two options, right? But there's actually three options because pressing B is a third option. And so you actually have to tell the game what happens when you press that third option, which in this case is just to just leave the menu without doing anything, or basically end the message flow. Okay, so let's look at an example of somewhere where you can't change time of day and what that looks like. So if I'm inside, I had to do a jump because I got caught off guard by the ability to transform indoors. I kind of forgot that the menu would look like this. But yeah, since we actually are able to, we have transform anywhere on, which means we can transform indoors. So let's see what happens. Okay, I guess you actually can. I wonder if it'll be like halfway through the door. Oh no, running animation. Okay. In any case, so you saw the options were transform because we have transform anywhere, and then we still have the something else option. So when we click this, there's no ability to change time of day in here. So it'll just go directly to hints because it would essentially be a single, like a menu where the only option is hints, and there are no one option menus. So we just do, we just go to hints directly. And so that is kind of comparable to in the vanilla game when you are in water, for example, and you press Z to open the menu. instead of getting like transform, warp, and then talk to Midna, since the only valid option would be talk to Midna, it just goes to that immediately. So that's kind of how it works here. So if there's no ability to change time of day, then we just go directly to hints. Okay, so when can you actually change time of day? So it's related to, or it's very based off the warp code. So like I can warp here, right? But I can't warp from inside. So we don't allow you to change time of day inside, but you can change time of day from here. And the most important additional check is, getting attacked. The most important additional check is related to if you're in a twilight, because in the vanilla game, if you're in a twilight, then you can warp normally. However, the time, there's no like time in a twilight. I think it might actually be set to like 0 as like the float value is 0. I don't remember. But yeah, changing time of day in a twilight is not valid. So if your current environment is a twilight state, then you can't change time of day. And it uses the same sort of checks for other stuff. So like if you're in a dungeon, you can't talk to Midna in warp, so therefore you can't talk to Midna and change time of day inside a dungeon either. Something interesting here. Let's see. Okay, there we go. So I have this like this. So you actually can change time of day from horseback as well. If we ever discover an issue with this, it's not a huge deal to change. But it's kind of like there's no I'm not doing the intense stuff to try to break it here, but I did do some stuff to try to break it, and it seemed like it was fine. So I would rather someone prove that there's like a problem with doing it before we remove it. But yeah, you can do both of those things from horseback. And the reason it's defaulting right to that menu is because when you're on horseback, it defaults right to change time of day. Or not, sorry, not change time of day. It would normally go to talk to Midna, right? But talking to Midna gets translated into our new menu. So it's kind of the same as when you're in water, where you can't transform and warp, but... Okay, I guess while we're here, I can go over an edge case. No, I'll go over that later. We don't need to worry about it. Or do we? I guess I can show. So we can... I'm gonna go up here because there's a... like a hint from Midna. Like, you know how sometimes you are playing the game and then Midna thinks you don't know what you're doing, and so it'll like pop up a Z button thing to kind of give you more of a hint on what you're doing. So here, for example, if I stand down here where you're supposed to jump across without let me make a save state. Okay, so if I press Z, like, we get this menu, right? But if I stay down here long enough, then Midna will pop up with Z and be like, sorry, these enemies might be pretty loud. Okay, so see how that popped up? Z. So if I press Z, interesting angle. So something on the other side, but unless there's a ledge to help us cross, we can't reach it. So that's basically the game saying, hey, you can't do this right now, so, you know, don't waste any more time here. And if we were to talk to Midna again, then we get that. Now if we were to leave the area, oops. So if we leave that little area, then we get the menu back. So basically I wanted to show that if there is an override, that we still respect the override. And another place you might see that is like in the middle of a boss fight. I think usually there's an override there. Let's see. Another one I want to show is using the Z jumps, which I don't even know if this is that related at all. But it is something where you might be like, well, that's a case where you press Z to interact with Midna, so does that still work? So I just want to show that, yes, this does still work. So here we go. So Z to jump here. So yeah, that does work as normal. I think here's multiple. So anyway, that stuff should be working as normal. But if we're not doing that, then, you know, we still have access to that. Okay, so that might be it for Midna. Let me think for a second, and then I'll jump if that was it. Oh, I guess one thing that I forgot to mention, but one of the goals, as stated, was we want to be able to change time of day without having Shadow Crystal, and we can actually do that. I'm not going to show it because I don't have a save set up, but since it's talking to Midna is the thing that resolves to our new menu, and we don't have a check in there for does the player have Shadow Crystal or not, then like as soon as you have Midna and you can talk to her, you have the ability to use this menu potentially, assuming it's an area where you're allowed to change time of day. So anyway, that's working as expected. But okay. So now I want to show an example of a non-flow thing. So if you look at the very top of the screen, you'll see where it says Future Jump Strike BYU. So that's the seed name. And so it showing up there is using some other code separate from the new stuff I've written. However, if we move into this file, you'll see where we have TV settings at the top, and then we have Future Jump Strike BYU there underneath it, where it normally says something about the squares. I wanted to put it on this screen also, because this is where most people are sitting. Like, this is the screen most people sit on before a race starts, and they press A, so it makes it easier to confirm that. And I didn't put it at the very top where it says TV settings, because if the name is long enough, then it'll wrap onto 2 lines in like a 1-line space, which obviously looks pretty jank. So anyway, but the important thing about this is that this is not actually part of a message flow or like a conversation with a NPC or something. It's just resource text, which is pulled out of a BMG file and displayed directly. So like all of the text on here, TV settings, that one, change the settings on the screen where it says complete in the top right, brightness check sample, that description, and then make the adjustments on the television. All of that is just raw stream data coming from the BMG file, and it's not actually part of a message flow. However, we're still able to change that using the new code. So over time, we might end up moving that, the existing code, which is stored in the C++ stuff, over to the actual generator side, where it's a little easier to change, and also it can use that exact same resource system which everything else is using, which is pretty fleshed out. Okay, so that's that. I also wanted to mention that all of the current text that was using the custom message data class and basically the stuff I've written is already moved over to the new system. So like the text here is using the new stuff, and the text here is using the new system. Okay, so yeah, just wanted to mention that. Okay, next thing. So I put a hint here, and I've shown a demo of this separately before. So you might recognize this if you've seen that one. But the first thing to point out is that we have two custom signs in the exact same room, which are doing different things or showing different text and whatnot. And that's because the signs are set up to use, like, each custom sign has its own flow ID or FLI value, which we'll go over later. But basically, it's no longer based on the room and stage and whatnot, the custom text. It's based on the flow ID, which is how signs in the vanilla game work. And so we're able to, we could have 10 different signs right here, and each of them could say different stuff. So that limitation is gone now, which is nice. Yeah, and the way it works currently, in order to minimize the number of instructions it takes to set the flow ID on the different signs when we're creating the actors and setting up the data on them, it uses the stage number, as we have it written in the code, as part of the flow ID or the FLI value. And that way, for most signs, we don't even have to write any code past the single line that's shared. So anyway, that's to say that the current pattern for how we're creating the flow IDs means we can have 16 different signs per stage, which we're nowhere near currently. So that can obviously be changed. Like, we could have 75 signs, per stage, or we could kind of do whatever we want, but that's the current pattern. Okay, let's talk about this fancy quiz hint sign, as I called it. So this is a completely custom flow, where we're doing more than just displaying a few text boxes. And while I'm talking about that, something else to mention. So you see how there's like one text and then two texts on the sign. Previously, we were limited to about 4, and the reason for that is that all of the text on the sign was actually one giant text thing. For EU and for US, it's 4 lines per text box. For JP, it's 3 lines. But it would just be one gigantic blob of text, and there's a limit to what you can do there. So the game would automatically split it into multiple text boxes after every 4 lines. Or if you had like double new line like this, then you could put, or would it be triple? You could put some empty lines, and then it would still center correctly in order to move to the next text box. But all that to say, that limitation of like, oh, we can only have about 4 hints per sign is now gone, because each text box is a new flow node, which we'll go over. And that means we're not hitting like a text cap on any individual node. So yeah, we can kind of do whatever we want. Now, obviously, if you're putting 15 hints on one sign, you probably don't want to do that, but it's no longer going to crash. So that's nice. Okay, but to look at this one, so this is a completely custom flow. You can go ahead and guess what the answer is. I'll give you a second. Okay, the correct answer is 7. So this is just custom text. I didn't bother like putting a hint here, but yeah, you could theoretically have like these quiz things like that. Also, so if you do the wrong answer, then we queue up an item, so a trap, ice trap in this case. And that's using a custom event function, which is another thing we can do. Yeah. Oops. So yeah, you can actually read this, but yeah, it's queued, so there's the same no escape from it as normal. Okay, what else? Oh yeah, I wanted to mention, obviously, here, like where we hit change time of day, that runs an custom event function as well. So anyway, we have custom event functions. We also have custom query functions, which are like the branch equivalent. So when we click something else here, we need to run a query function which checks, do they have the ability to change time of day based on the current game state? And so that's a custom query function. So we'll get to that later, but yeah, we do have the ability to have custom query functions and custom event functions for message flows now, which is nice. Okay, final thing. And so that fancy quiz hint sign, that's not actually going to be there. That's more just like showing the capabilities based on this work. There's another one I want to show, which is a capability based on this work that's not part of the initial pull requests. But if you look here, so I have a RAM viewer open. So like watch my rupee count. So basically I have a RAM viewer open to where I can adjust my rupees as I'm playing. So, okay. So this is Seeds 50. The reason it shows as a blue rupee is because I don't have a slingshot, which if you've played the rando, you're probably familiar with that. But okay, so if I buy this, it would be a blue rupee at this point. The thing to notice here is see how it says it's 55 rupees? That's because I went in and changed it to have the cost be 55, and so that updates in the text. And we could already update the text previously because this was already custom text. However, the price would still be 30 rupees. And the reason is that the two major points that we need to change are when I click on this, the game checks how many rupees does the player currently have. So if it's 30 or more, then they're allowed to buy it. If it's less than 30, then it would show this text box, which is the you can't afford this text box. So the first thing that we had to change was that branch. We changed the parameter on that query function to, instead of comparing at 30, now it compares to 55. So let me show that. Okay, so if you look at my rupees in the bottom right, it's at 54, which means I don't have enough. Okay, so it says they're 55 and you can't afford it, so that's working as expected. Now if I go up one and I'm at 55, so now it says they're 55, do you want to buy them? I guess I could actually update this option text now, but anyway. So it says it instead of them. Technically, I guess them would be better, but moving on. Okay, so 37 hex. So that, we can afford it at that point. If we go up to like 56, we can afford it. So the checks are working correctly. Now, the other thing that happens is when I actually go through and buy this, it runs through several event nodes to do actions, but one of those event nodes will be subtract the price rupees from the player's wallet. And so by default, that event function has a parameter of 30, which means to subtract 30 rupees from the player's wallet. But since we're adjusting the price to 55, we actually want to adjust that to subtract 55 rupees from the player's wallet. So if I buy this, okay, and I'll just wait here for a second. So yeah, you can see that the rupees went down to 1 because we were at 56, so we did subtract 55 correctly. And then now that I get this, I'll go up to 6 because I got a blue rupee there. So that's an example of a custom shop price, which actually, believe it or not, is very trivial to implement from a from the perspective of adjusting the message flow. So with the new code, this won't be part of like the initial PR, but once we get the logic working correctly, which will be the actual bottleneck, I guess, or the block. But anyway, once we get the logic working correctly, actually going through and changing these prices is pretty trivial. So that feature is something that comes out of this effort, but it won't be in the first release. But anyway, that's something to look forward to. But yeah, I think with that might be the end of the demo for now. Next, we'll be getting into the technical part of the presentation, which is where if you are not involved in the coding, then you'll probably care less, so feel free to drop off at this point. But if you are interested, then obviously you can keep watching. But yeah, that'll be the end of the demo for now. So, all right, I'm back from a bit of a break, so apologize if the voice sounds different. We'll be getting into the technical part now. I'll include info about how the code that I've written works, that whole system. But a lot of this is actually going to be just making sure that we understand how this stuff works in the first place, because that's kind of necessary to to understand how the code in the system works. So yeah, we'll start with talking about general BMG stuff and then move into the actual new system code, whatever stuff. And then after that, we'll move into some more general message flow stuff, talk about like tags within the strings and how menus work and stuff like that. But okay, so from this work, what did we end up with? So we have a system to make changes to message flows. So an example of that was changing the price of the slingshot. And then we can have fully custom message flows. So an example of that was the that quiz hint sign asking about the chickens in Lake Hylia. And then we can kind of combine them a bit also. So we have like talking to Midna, which is a vanilla flow. Well, there's multiple, but it's a vanilla flow in the game. Well, actually, I guess it's kind of one flow, but anyway, we'll talk about that later. But we kind of merged the existing flow with a new custom flow, so we can kind of do quite a lot there. Also, there's a site for viewing BMG files, which I used. I had to build that. It's based off some other code that I had happened to do in the past, so I already had a starting point. But it's not part of the rando, but it helps a lot for viewing the BMG files and the graphs. And so it'll be helpful for rando development going forward. I'll have to do a little more work before that's ready to go public, but I'll be showing its somewhat jank current state to show some of the stuff I'm talking about as we're going through this stuff. Okay, so the first thing to go over is what is actually in a BMG file. And no, I don't actually know what BMG stands for. I think there's multiple files that start with B where it's like binary, so maybe it's binary message, I don't know. But it's BMG, which is easy to get confused with BGM. But anyway, so it contains the text that shows up in the game. So imagine we have an ID and that translates into text. And so this is kind of how a lot of resource systems work, where you have like this ID, and then depending on which language you're in, the ID, when it resolves to the text, it will be different contents, or if it's English versus French versus Japanese and so on. And then the BMG file, not only does it contain text which is used in message flows, such as when you're parts of conversations, as shown earlier, it also contains just raw text, which isn't part of a flow. The example that I'll use several times throughout this is TV settings. So that's just a string that appears on screen, but it's not actually part of a message flow. Some other stuff that's included in the BMG file, how a text box should look. So if we're talking to Midna, there's like the Midna facial expressions and the Midna styling where you have like the blue text and then Midna's talking. I'm not sure what part of the code that comes from. But then we have other kinds of styles where it's like, is it a large sign that kind of blocks the whole screen, such as the one outside Agatha's place? Or is it just the basic text box at the bottom? And then also, the position of the text box is at the top of the screen, which you see with the gate keys item, for example. I don't know. There's probably other stuff that uses the top of the screen, but some other stuff in the BMG file. So how does a conversation flow? So if we look at that slingshot example, when you're buying the item or you're trying to buy an item, it can either branch to the like, you can't afford this, or it goes to the, are you sure you want to buy this thing? And then it also handles like translating the flow ID of something into the actual flow. So when I read a sign somewhere, how does it know what flow to load in? You don't want to read a sign and then suddenly it's like loading the completely wrong conversation. So also some stuff that's within this file, you have like event nodes where it will run a function which will update some kind of state. So a pretty common one is setting flags. Multiple different kinds of ways to set flags. There's also reading flags in like branches. Or subtracting rupees when you buy something. That's another example of an event. Okay, so now let's get a little bit of a better understanding of what a message flow looks like. So let me show the talking to Midna graph. And I'll use the term subgraph because as you'll see, well, let's look at what a graph looks like, right? So this is the BMG viewer site I've worked on. So there's a few things going on here. So a triangle is a branch. So you can see they have arrows that go between things. The diamonds are event nodes. There's also say branch and event. And then the circles are the message nodes. Actually, that green color is left over from something I was messing with a long time ago. So you can ignore that. This bright blue one is like the start point for this for the graph. And then if we get to one where there's like there's no node following it, then that's because the next flow index would be FFFF, which means there's nothing after that. And FFFF is what indicates that the flow ends. But the reason they're called subgraphs is because they actually can send to each other. So when you first start talking to Midna, for example, this is actually where you start. I have these queries marked with like a short description. So the very first thing checks, are you underwater or swimming? So 0, let's see, 0 would be that you are not, 1 would be that you are for this query. And so event index 9 sends you to a different subgraph, and event param 0 means that we're going to resolve to the subgraph based on whatever talking to Midna should be. But let's say you're not swimming, then we have this query checking if an event bit is set. So if there's no event bit, or there is the event bit. And so this is checking, this is from decomp, these values here. But it's checking if you have the shadow crystal. If you do have the shadow crystal, then event index 9, we're going to change to a different subgraph using the flow ID or the FLI value BCF. And that actually sends you back to this one. So yeah, the reason I might call them subgraphs or subgraphs in different locations is because they actually do connect to each other in some cases, like in that way. So, okay, let's see. Talking to Midna. So yeah, talking to Midna obviously is extremely complicated. even more than what you're seeing here, but we'll go over that a lot later. Sarah's slingshot graph, let me pause while I find that one. Okay. Yeah, I had to look up what was going on there. So there's these different files, which I'll go over in a minute as well. zel00.bmg, I don't have .bmg on these, but this is like the global file, and these other ones are based on the stage. But zel01 is for like all the Ordon stages, so the ranch, the spring, the village. And we'll check on that. But I do have where you can... Oh, whoops, not that one. Okay, here we go. So these are different flows. And we start here. So this is where we're checking query for compares current rupees against either wallet max or param value, question mark. Yeah, some of these I could probably fix. But if we look at the query params, for example, that's 1E, which is 30 decimal. And so we're comparing your current rupees against 30. And so in the one case where you can afford it, we go this way. In the case where you can't afford it, we'll go here, where we say you can't afford it. And in a lot of cases, the 0 and 1 can get kind of confusing if you think of them as true and false. Generally speaking, the positive option is going to be first. Think of it as like an array where like you have index 0, index 1, index 2. And so generally speaking, like if we were to look at a menu, we're like, okay, yes or no, right? So it's like first option, yes, yes. Second option, no. So yes is actually going to be index 0, no would be index 1. But if you're thinking of it like a Boolean, then that might be backwards in a lot of cases. But we can also just tell by looking here. Okay, so that's an example of where the comparison happens. And then if you want to buy it, here's your choice. Like either you buy it or you don't buy it. And this is actually where the graph ends. So if you don't buy it, we just go directly here and then we end after that. Or if you do buy it, we go this way and you can see there's a ton of events happening before we get there. So one of these, if we find the one that has parameter 1E. So yeah, this 4CF, I don't have the events written out yet to where like the branch, for example, shows the query and then I have my here's what it does thing. I don't have that here for the events yet, but I'll handle that, or I'll work on that. But yeah, so this is, I believe, the one that we have that 1E parameter, and this is what actually handles subtracting your rupees, for example. Okay, let's explain BMG files 0 through 8. Yeah, so you have zel_00.bmg or 01 and whatnot. There's also a zel_99, which you might have seen in the decomp. It was used for testing the message flow system, and it's only present on the JP disk. So yeah, you can see for US we have 0 through 8. And then I have these different EU language ones. So if we go to French, for example, yeah, so you can see the French there. Now if we go to JP, same thing. And I have the Furigana filtered out, so it's actually readable. Otherwise, it's completely unreadable. But if we go to zel99, and let me clear this because I think it'll try to do something there. Okay, whoops. Yeah, sorry. This is still a work in progress, so I haven't fixed all the crashes. But okay, so like if we get here, we have some events. We'll go over this in a lot of detail later, but this sets up the menu, and then we have the check, or not the check, sorry, the message box at the bottom of the screen, and then these three would be the options over on the right screen. And you can tell this is like a test file because it's like, what do you want to check? And then it's, do you want to check, this is like your movement action kind of thing. So like the actor doing something, and then this will be like the facial expression. So the first option will be checking both of them, which is over here. And then the second one is I only want to check like the action. So that's like the NPC. Imagine they like do some gesture when they talk or something like that. I believe that's what that is. And then you have facial expression only. So yeah, there's a lot of different ones there. Let's look at a few of these. Yeah, this one's interesting. It's like someone who is stuck here, I think. Asking if you're like an adventurer. I think it's kind of funny. I believe this is Uku. Pretty sure. Yeah, I'm like very sure that's Uku. That's kind of complicated. This one's all katakana. Anyway, it's pretty interesting if you go through these. I do plan to try to. That's another Uku one. I do plan to try to provide a translated version of this. This one's super interesting because it's literally, it's like, is this a two option selection thing? And then you have yes or no. It seems like your either selection doesn't matter, just leads to this other one. And then it's like, is this a 3 selection one? How about it? I guess. It's like it's a 3 selection one. How would you translate that? I don't think so, I guess. Or like, I'm not sure. Okay. Anyway, this is like the perfect example of how this is a test file, in my opinion, which I might have already said, but I think it's pretty undeniable if you look at that one. That's the same kind of thing. Oh, and then here's another one. So it's like setting a temporary flag on, turning the temporary flag off. Oh yeah, this one's kind of interesting because it's like milk. I guess that maybe they get replacement milk every day or something. But yeah, it's 15 rupees for milk, I think. Well, I guess you can buy milk in the... I wonder if that was... What's his name, that bird? Trill? I don't know. But anyway, you can go through these. They're like super interesting. But yeah, I'll work on trying to provide a translation for that. But in any case, this Zel99 is only available on the JP one because obviously they developed the game in JP and there's no reason to translate your test data, you know. Okay. Anyway, moving on. Okay, so which BMG files are loaded? So the Zel001 is like your global file, which contains things like the Midna menus and like talking to Uku, and when you like fish up a fish, and then there's text there. I have more about this stuff on, I guess, the next slide. But yeah, here's some other ones. So like everything after 0 is only loaded based on your current stage, I believe. And they're kind of grouped in a logical way. So like Zel01 is all the Ordon stuff, and Zel02 is like all the Kakariko village stuff. But let's go ahead and look here. So here's a better description. So yeah, Zel00, this is the one that's available no matter what stage you're on. The other ones are stage dependent, and then Zel99 is that. I don't believe it's actually used anywhere. It was one they just used for testing the message flow system out, and it's only on the JP disk. And when I talk about like only on JP, just keep in mind that I only looked at GameCube for these things. It should be very close, like almost the same for Wii on all these messages, I'm assuming, other than things where it's like referring to buttons on the controller or something. I guess those would have different text. Maybe other minor things, but anyway, just keep in mind I'm talking about GameCube. Okay, So Zel00 available everywhere. Midna, the pause menu text, Uku Jr., and I'm assuming some Uku related stuff. Anyway, maybe just Uku Jr. Caught something while fishing. Great Fairy at the Springs. Whenever you're learning a scent, talking to Epona, which is interesting. If you didn't know, you can actually, as Wolf, you can talk to Epona, but obviously that could happen on essentially any different, obviously not every stage in the game, but a lot of different stages. So that's why it's available in this file globally. You got this item text, I believe that's in here also, and then there's some different cutscene text. In terms of how message flows and cutscenes interact and whatnot, that's not something, it's kind of out of the scope of what I've done here. Which isn't to say we didn't get a lot done, obviously, but you have to draw the line somewhere. And in terms of the stuff we're trying to do in the rando right now anyway, figuring out how message flows and cutscenes work, like figuring out how cutscenes work is obviously a gigantic undertaking. So there is some text that where it's like, oh yeah, this is definitely from such and such cutscene, I believe. But also there's some text in the credits. But yeah, then we'll look at these ones. Zel01, or I'll just say 1, Ordon. 2 is all the Kakariko stuff. 3 is Death Mountain, which interestingly gets its own BMG file, which I didn't think there was that much text at Death Mountain, but maybe there is, for it to get its entire own file. A lot of these files will be like, over here on the higher numbers especially, they're shared between kind of unrelated areas, I guess, where there's not that much text. But 4, this one's nice to know, this is like Castletown stuff. 5 is all the dungeon stuff. Grottos and caves. But anyway, like every single dungeon in the game, all the boss stages and the mini boss stages. Are those? Yeah, I guess those are their own stage, maybe. Grottos and caves. LA, I think that's the Light Arrows cutscene. But yeah, if it's a dungeon, then it's in Zel 05 pretty much. Zel 06. So here's where we have unrelated stuff, kind of all just thrown together. Farron Woods and Interiors, which I believe is like inside Cora's house. I don't even know if there's another Farron Woods interior. Snow Peak, not the dungeon, but the area. Sacred Grove, this is Bulblin Camp, Grotto Desert, Mirror Chamber, Hidden Village, and Interiors, which Hidden Village Interiors I think is Impa Z's house. Which I say because it sounds like Frank Rizzi. Anyway. Hidden Skill, that area where you learn hidden skills. Zel 07, Zora's Domain, Fishing Hole, Henna's House. Zel 08, this is Hyrule Field, so this is the entire gigantic Hyrule Field ring. So like Kakariko Gorge, Elden Field, the North Elden area, or whatever you want to call that. Linear Field, Great Bridge of Hylia, and Farron Field, as we would call them in Rando. But yeah, that gigantic ring would be Hyrule Field. Outside Castletown, which is like south of Castletown to the west side of Castletown for GameCube. The east side with the Poe, I believe that's the same stage. Lake Hylia, Upper Zora's River, and Zora's River. So Upper Zora's River is, at the top. I believe Zora's River is like when you're actually in the middle of the mini games. So for example, when you first blow up the Izaroks, and you're talking to the Zora, that text might be in Solo 8, possibly. The King Bulblin 2 fight, and then the title screen text in some way. I think some of this might have been copied from Decomp or something. And then as we've seen, we already spent a bunch of time on Zel 99. But yeah, just know Zel 99 is not actually used just when you're playing the game, I'm pretty sure. So that is to say, there are 9 BMG files we're concerned with. 8 of them are loaded depending on the stage, and then the Zel00 is available globally all the time, basically. Okay, now let's talk about the BMG format. So we'll look at Zel00 to show the stuff here. Keep in mind there's also, I believe, like a zel_unit.bmg, and that is for stuff like bombs, different units, and like their plurals and stuff. It doesn't have these same kinds of like the inf1 data chunk. it has different stuff. So I'm specifically talking about Zel 0 through 08 and then 99 when I'm talking about all this BMG stuff. Okay, so data block headers, that's an important thing. So the very top, you'll have this message BMG1 thing, and that's just marking the type of file, and then you'll have this general header stuff. Most of this at the end is probably padding. I think this 5 here is saying how many sections there are, if I recall correctly. And then the start of each data chunk is going to have 8 bytes used. So the first 4 will be the name of the chunk, and then the next 4 will be how many bytes you would have to jump to get to the next chunk, essentially. So if we go from here, 186C0. So we can jump hex relative to our current offset. We want to go 186C0, and then we'll jump, and then that takes us to this date 1, like data 1, whatever you want to call it, section, which is just a giant string table. In fact, after the first 8 bytes, so you see date 1, and then here, so that's, I will jump to the next one. So 2CA80 from here. All right, and then we're at this next section, mid 1, 4E40. So if we go 4E40, now we're at flow 1. And then we'll go 15C0, and I'll explain what each of these sections means. FLI1 is the final section in all of these. You can see 280 would be how far it would be to the next section. So if I'm going to go 270, 270. So see, 270 puts us here. 280 would put us at the next one. I'm assuming these are aligned to 16 bytes or 32 bytes, I'm not sure. But that's basically not the actual literal length of the section. It's how far, where is it here? It's how far we would go if we were jumping to the next section. But if we go all the way back up to the top, this 5 means that that's how we keep track of once we're actually done. So we look at a section starting right after the header, so 32 bytes. And then we do a string compare on the header name. And if it's not the one we're looking for, then we jump to the next one. And we know that we can only do that up to, for the 5 different ones. And let's see. So jump. Okay, apparently aligned to 20 or 32 bytes. I'm going to trust that I did that correctly. Okay, and let's look at it in the decomp code. So let me pull that up. Okay. So here we can see get message data block. Okay, so here's an example of where it's used. Get message data block with the inf1, flow1, FLI1. Also keep in mind, I didn't want to change partway through doing this, so the decomp commit I'm on is probably 5 or 6 months old at this point, maybe 6. So it's possible they've updated all the decomp stuff slightly. Well, okay, they've definitely updated it within the last 6 months, but what I mean is the files I'm going to show specifically might be slightly out of date in terms of them updating it, but it's not really important. Anyway, so this is looking at what I was just talking about. So the block tag would be, not that, sorry. Okay, inf1, as we saw, that's like the block tag. And so we're basically doing the string compares. If not, we're reading the int value from offset 4 and jumping that far. Anyway, but this is basically the function that does the stuff I just went over. 2 zeros because that's how big the header is, I believe. And then this offset C is here, and that's how many times we can check. Otherwise, we return null pointer if we don't find anything. But all right. Okay. So let's talk about the data blocks that we just looked at, the different types. So you have this inf1 section. It handles things like what does the text box look like, and we've already gone over those examples. It also has things like the gesture and facial expression of the person you're talking to, I believe, and different stuff. But anyway, the most important thing is that it points to the offset in the date1 section, which, as we saw, was a giant string table. It points to that string essentially. So the inf1 points to a string in the giant string table. Mid1, so this is like, I guess, info data. Mid1, I'm like 95, 90. I'm like pretty confident this means message ID is what that's short for. This section is pretty confusing. We'll go over it in a little. Yeah. So message IDs, which map back to inf entries. For TP, you can kind of ignore it. I'm wondering if maybe for other games using the whole JSystem stuff, maybe it has more of a purpose, but for TP, it appears to not really do much. But yeah, we'll go into a lot more detail about that. Then you have what I'm assume is flow section. It contains the nodes within the graph. So if we look here, for example, each one of these nodes, branch, event, or message, these are flow nodes. And yeah, this flow section defines those nodes. And then it also has a second table in it, which we'll talk about, which handles like, okay, I have a branch result of this. How do I know which node to go to from there? And then finally, we have the FLI section, which is flow IDs. And it's very simple. It's just this flow ID starts on this flow node index. Okay, so here is some visualizations of how these sections are related. So if we're in a message flow, the flow starts on the flow ID. So we have here the flow ID maps to a flow node, and then flow nodes kind of map to each other using the next node table, and we'll go into detail about all this. But also the flow node will point to an inf entry, and it'll have a message ID, which will be found in this mid section, and then that maps back to an inf entry. And then the inf entry also points to the data in the string table. So when you're in a message flow, which is like when you're talking to something or like reading a sign, there's all this going on. Aside from that, we also just have direct string lookups, which is like the TV settings screen I was talking about, where it's like we have an inf entry, or like an index of an inf entry. So for example, entry 4D, or well, we'll say like 5B3. That's an example. And that will be an index in the inf entries, and then that entry is going to have a 4-byte integer, which is like an offset in the string table. And so we can use that inf index, which is kind of like the ID, and translate that into the string. Okay, let's talk about FLI entries. So we'll look at this. This is the zel00 BMG file, by the way. FLI1 starts here. It has a 10-byte header, or not 10, sorry, 10 hex, which is 16 bytes. But yeah, one row of header, and then the actual entries are here, and they're 8 bytes each. And you might notice it's like value, then 0000, so 2 0 bytes, and then another 2-byte value, and then more 0 bytes. And you can see these are all 0. But yeah, the first thing is the flow ID, or I'll also call it the FLI value in different places, but that was before I settled on, I'm like, yeah, this is probably the flow ID. But what we're doing is essentially mapping this flow ID to this node index, the FLW index, to start at. So for example, if let's look at BB9, maps to 1B. So on the graph website, if I go to 1B, see how it's blue, and it's the start of the graph? So if we were to look at flow ID BB9, then we'll start here. And BB9 is the one that is used by Midna when you first pull her up by pressing Z. It goes here. And then this graph, as we've gone over, can go to different sections. So over here, for example, is during a twilight. And you'll see there's actually this interesting thing where you're not allowed to warp at a portion. But okay. So yeah, so we have the flow ID mapping to what flow node to start at. Oops, back here. Okay, and as I did, there's a lot of things where I went through with a script and whatnot and confirmed, is this true for every single file, for every single language and region and whatnot? And so I did confirm that offset 2 and 6 for the 8-byte entry it is 0 in all cases, and I don't believe these are used. So I do think they're just padding. So the entries could have been 4 bytes each probably, but for whatever reason they're 8 bytes. So, but okay. Example entry in Zel04. Graph site and hex viewer. Well, here's the hex, so we'll skip over showing it in the hex viewer. Get rid of that. So if we go to Zel04, this is the Castletown one. Isn't this fun? Yeah, this is bomb bag stuff. It's they're all like this. It's crazy. Okay. So if we have flow ID 641, and that leads to 9A6 as the starting node. So let's do 9A6, which will be this blue one. So this is the Castletown oil cellar Goron. So flow ID would be 641, and so you could say Castletown oil shop Goron conversation is flow ID 641. So that's kind of the identifier for a specific conversation. So I'm assuming that NPC has a parameter defined on it probably for this flow ID. We could look in the ultimate TP spreadsheet to see where this 641 shows up, but that's how it is for signs and stuff. So I assume it works the same way for this actor. Okay, but yeah, it indicates that the initial flow node is at index 9A6. So yeah, something interesting that I noticed with this graph here, and I still need to fix this, so don't want to forget. But there was someone in the Discord who ran into this issue where they said that they talked to the oil Goron and he didn't actually say what his item was, like his replaced randomized item, which we had fixed. And so it's well, that doesn't make a lot of sense. But then I realized when I was looking through here that this Midna revived Hyrule Castle barrier appears. This is once you complete MDH, it actually splits off into different sections. There's quite a lot going on for this one Goron. But the problem was that I had only done it for post MDH, which is this way. And I think they had not done MDH, which means they were over here. So we hadn't replaced the text correctly there. So yeah, I was able to find that bug, which I still need to fix. But okay. All right, next we'll talk about the FLW chunk, like that. So this one is pretty interesting because it's actually, you have the date one section, which is just a string table, but the rest of them are an array of entries. However, the FLW chunk actually contains 2 different tables in it, as we saw right here. So all of them, they kind of have one kind of thing in them, but this one actually has 2. And so the flow nodes, these are the entries. So like the, if we look at the graph, the dots are the nodes with the lines going between them. So the flow nodes are each of these things that you can click on there. And then the next node table is how we translate a result from like a branch. And technically events use these as well, but it's how we translate a branch into its results. So if we look at this one, this is like when you're talking to Midna trying to transform, and there's like a very large number of reasons it can fail. So yeah, this branch actually has 5 different results. And so how do we translate, we're processing this branch node, how do we translate the result into the actual node index we need to go to? So like how does 0 translate into 187, and 1 into 189, and 2 into 18A, and 3 into 186, and 4 into 180. So that's what the next node table is for handling, or it handles. Yeah, the entries are U16s in the next node table, and each value is a flow entry index, or FFFF to end. Okay, so within the flow entries, there are, each is 8 bytes, and there are 3 types, which are message, branch, and event, as we've seen in the graph. So events are these ones, which do things. Branches are when we can branch differently based on game state. And then messages are like the text. And menus with options, those are actually across 2 nodes. But we'll go into stupid amounts of detail on menus later. Okay, that's should be enough about this one. Okay, so let's talk about message flow nodes. These are used for displaying text. They also point to their next node directly, so they don't use the next node table. So for example, next flow index FFFF, here's one, next flow index 1AA, so you can see it just points directly to 1AA, and then this one points to 193, so those ones are very straightforward. And then for a select message, which is text box plus options, text box is one message node and the options are another message node, which we'll talk about later, but that's what's going on right here. So the text box at the bottom is one node, and the options on the right are actually a second node. Okay, now we'll talk about branches. That's these ones I have marked as triangles, where you do a query function, and you'll get a result, and then you'll branch based on that result. So just to go over some different ones, at a shop, can they afford this item? Here's a good example. When you're leaving Agatha, should she say that I know you have bugs line, right? So it's an example of like, based on the current game state, different things could happen. And when you press Z to talk on Midna, what menu should show? For example, should it be a menu that has warp in it? Should be a transform into human menu or transform into wolf menu? Do you have shadow crystal? Like, should we even let you transform? Stuff like that, which we've talked about. Okay, and then the final of the 3 flow node types is an event type. And this one, so messages and branches are kind of the very well-defined ones, and then events is kind of the less well-defined one, but basically if it's not a message and it's not a branch, then it's an event. These are the things that handle the doing that needs to happen, so like updating game state. So here's some example of things that event nodes can do. Setting flags, adjusting rupees, health oil, different things. There's like a rental bomb bag event stuff, donation stuff. When I was looking at them, it looked like one of them could play a sound effect, but I'm not 100% sure on that. But yeah, there's basically just a bunch of different stuff event nodes can do. And so, yeah, when we're going through a message flow, the nodes will proc until one of them hits a result indicating to stop. So if you recall when we looked at the Sarah Slingshot one, or does this one? Oh no, this is the Midna menu. But yeah, if you recall the Sarah Slingshot one, which was like 5 here. Oh, whoops, I'm in the wrong file. Zel01s for Ordon. Actually, let's do this one. 4 CA. Okay, here we go. Yeah, so if you recall on this one, it runs like several events in a row, but it's not like each one of these takes 1 frame. They kind of we just keep looping until we hit a stop point, basically. I believe that's how that works. Oh yeah, here's the example. When you buy the slingshot, there's 6 different nodes. 1, 2, 3, 4, 5, 6. Yeah, that run. Okay. Okay, now let's go more into the actual contents of the flow nodes. So the very first byte for any of them is going to be the type, which for a message type is going to be 1 as the value there. So let's look in this one. Okay, so after the 10 byte header, so these every 8 bytes is going to be a flow node. So let's see if we can find one. Like here's one where the type is 1. The second byte of specifically a message type is always 0, 0. This is just padding. I know we had thought maybe it was related to other stuff, but I looked through the code and there's only one place it could possibly ever be read, but it's not. And even if it was read and used for that for message nodes, it would be having a value of 0 wouldn't do anything. But anyway, the value there is literally 0 for every message node in every file, in every language, in every region. So I'm calling it padding. Okay, and then offset 2 is the inf index. So imagine I'm a message node. Like how do we get from a message node to the actual string text? Well, we go message node points to the inf entry, and that points to an offset in the string table. So there's a bit of a chain going on there, but if we just click on this one, for example, you can see the inf index is 5b6. So if we were to go to the inf entries and then go to index 5b6, that would be the entry that this message node is pointing to. And then offset 4 is 2 bytes for the next flow index, or FFFF if there is no next one, which will end the message flow. And so, for example, 4D5, so this 4D0, its next flow index is 4D5, and that's how we go from here to here. And then 06, this is like more unused. You could call it padding. I don't think anywhere in the code uses it. There is, and the reason I don't just say, oh, it's padding, is that there's a bit of an interesting pattern here. So the padding in all these places is just 0 the entire time. But for whatever reason, for this one, if the next flow index, which is offset 4, if that is FFFF, then this value is also, is always FF00. Otherwise, it's always all zeros. So let's see if we can find an example. So see how it's all 0 for these ones. And then here's an example of a message node that just points to nothing for the next node. And so it's FF00. So it's almost like whatever they were using to write in these bytes kind of just wrote in all 4 at the same time or something like that. But in any case, I don't think these are used, but that's what the pattern is regardless. Okay, let's look at this flow message node example. So if we pull open cell00, go to the flow section, and then here is the first node. So we want node D0. And so what I can do is if I jump forward D0 bytes 8 times, since we need to go through 2 index D0, and each one is 8 long, if I jump forward D0 bytes 8 times, or I could multiply D0 times 8 and jump forward that many. But I'll just go 1, 2, 3, 4, 5, 6, 7, 8 in order to get here. And so we have this right here. So those would be the 8 bytes that I copied here. So 01's the type, next byte is padding, which is always 0, and then A03 oops, A03 is the inf index, and then the entry at that has a pointer to the date1 chunk in there, which has a string value, which is the Hooray Tazala one. And then FFFF means that there is no next node after that. So once you have this text, then it just ends the flow after you press A to go through that text. And then the last 2 bytes are those unused ones, which happen to be FF00 since the previous 2 bytes were FFFF. Okay. All right, next, let's talk about the branch flow node type. So the first byte for a branch node is going to be type 2. The byte at index 1, this was also one that was kind of confusing to find, but it also isn't used by the game code, but it's the number of possible query results. So if the number was 3, then the possible query results would have length 3 starting at index 0, so it would basically be 0, 1, 2. And then offset 2, that's a U16. It's an index in the M query list in the, here we go, M query list. All right, here it is. Important to know that like query 005 is actually at index 0. Some of them line up, like query 001 is at index 1, 2, 3, and then 4 is 6, you know, and then the query 004 is here. So for queries, they kind of don't really line up. But then also, as you get further down, so this would be 4, 8, 12, 16, 20. So you can see the query number, once you make it past the beginning where they're like completely out of order, they're actually off by 1, which is interesting. So this is index 20, but the query is actually 21. So there's also another one that's very similar. The event list, which we haven't gotten to the event node type, but it's basically the same. But if we look 0, 1, 2, 3, 4, 5, 6, 7, 8, these ones appear to actually be normal the entire way. Interesting. Yeah, so the event ones appear to line up. So like event index 0 is event 000, and event index 22 is event 022. However, for the query list, they don't line up. So just keep that in mind. But okay, so the query index is an index in the query list. 2, these point to a function, and it's not, you would think it'd be 4 bytes, but technically they're the PTMF, which I think is pointer to member function, I think. So they're actually 12 bytes apiece for the entries in this. But we don't really need to worry about that for now. Okay, and then offset 4 in the 8-byte branch is going to be query params, and we'll pull up an example in the hex viewer in just a second. And the query params are used by the query function. So for example, the one when we were buying the slingshot and we needed to compare, does the user have 55 rupees rather than the vanilla 30? That, like, how many rupees are we comparing against, 30 or 55 or whatever? That would be in the query params. And then offset 6 is the next node table base index. And we'll go over that, but essentially how it works. Let's refresh, and we'll look at this example where we can have 5 different results, 0 through 4. The base index, what we would do is look in the next node table. So that base index plus 0, the value there would be 187. The base index plus 1, the value there would be 189. Base index plus 2, the value there would be 188. And so we take the query result and use that as sort of an index in the array, which starts at the next node base index. So I guess while we're here, let's go ahead and show this example. Okay, so this branch is flow index 188. So I'll jump forward from my current offset 188 hex, and I will do that 2, 2, 3, 4, 5, 6, 7, 8 times. And so you can see how these values line up. So 2, 5, 2, 9, 0, 10A. So 2, 5, 2, 9, 0, 10A. And so the next node base index is 10A. So how do we actually find the next node table? Well, we need to skip over the flow nodes. And so I believe 21A is how many, is that correct? How many flow nodes there are? I guess so. 1, 2, 3, 4, 8. Okay, you can kind of see how the values look different. So these are all the 8 byte ones, and then these ones are only, they're just U16s, so they're 2 bytes apiece. Okay, but now that we're here, we want to go forward 10A bytes. So this would be like next node table index 0, next node table index 1, next node table index 2, and so we need to go to 10A. 10A. So I do that twice to jump forward 10A times 2 bytes, since each entry is 2 bytes long. Okay, so you can see 187 is at index 0 relative to our base offset. And then 1, if we add 1 based on the query result, then we get 189, which lines up here. And then the next one, if we add 2, is 18A, which lines up here. So we add 2 to get the index at offset 2 relative to the base. And then 3, 186, and then 1AD for 4 right here. And then it just keeps going. So like this is going to be used by some other thing that's pointing within this next node table. But that's kind of how branches work. So node 1A3 can have results. Okay, so we looked at 188. I was talking about 1A3. Do we need to show that one? Also show for 1A7. Okay, 1A7 looks like 188, which we just showed. It's basically the same thing. So I'll show this 1A3 one. Just to reinforce it. Okay, so 21A. Okay, so this is the start of the next node table. And then 1A3 has base offset 12E. So 12E. Okay, and you can see offset 0 is 1A7, offset 2, or sorry, offset 1, index 1 is 1A4, and then index 2 is FF. So for this one specifically, if you look, the number of query results is 3. But that's weird. I only see 0 and 1. It's because the way I have this rendering, if the arrow would point to FFFF, which isn't a real node, and would indicate the end of a message flow, then it doesn't point to anything. So 2. So if our result from the query was 2, then we point to FFFF. And how do we get result 2 in the case of a 2-item menu? Transform into wolf is 0, index 0. Talk to Midna would be index 1, and then pressing B to back out would be index 2, or like query result 2 in this case. Yeah, okay, we have that written here. So for a 2-option menu with a hidden result, that's when we use query 36, and then it returns the select option index or 2 for the hidden result. And so the hidden result would be FFFF. So I guess I'm glad I did show that one. We don't need to show 1A7 because I showed one that was just like that. Okay, let's talk about offset 1 in the branch node. So here, for example, we have results 0 through 4. And so the number of query results is 5. So it took a bit to figure out what the pattern was here. And that's because this is another one where the game code doesn't actually use this value for anything. but yeah, that's what it is. So then the question is, okay, if the game code's not using it, then why is it there? And my guess is that it's so you can insert a BMG file into a BMG viewer or editor software and then have it like render correctly. So I'm assuming when they were working on the game, they probably had something very similar to what I'm showing here, where like you can see how the nodes connect and everything, because this makes it like infinitely easier to work with. And I'm assuming the number there was used by the software in order to figure out how to draw stuff. What I was doing for this was I like went through literally every query function. So like this one, I went through, I'm like, looks like it's related to Midna, and then I see it can return these values. And I have that kind of hard-coded in like, oh, it's this query index, which means it can have these results. But if at the time I knew that, oh, I can just look at number of query results, so 5 means the results can be 0 through 4, then I wouldn't actually need to do that. And in fact, that's probably a better way to do it, and I'm likely will update the code to work that way. But anyway, I'm assuming that's what this value is. And so you can kind of see how that pattern lines up. I did want to show some ones that are very interesting. So if we have a query function that is checking what the current in-game hour is, then you can actually have 24 different results for that, which will look very funny. So if we go to Zel04, that's for Castletown. And then we're going to look at node 1AC, right? So it's like, wow, that's pretty crazy. So this is, excuse me, terribly sorry, unpolished, filthy shoes. So this is the guy out front of the what eventually becomes the Castletown Malomart, and you can see this is how it checks checks if they're open. So it runs this query. So here's, if assuming we don't have the Malomart stuff already done, then we make it to this query function. And so what this does is it gets the current in-game hour, so the results between 0 and 23. And basically get time is like a sky angle between 0 and 360 or whatever, and divide it into 24 equal chunks. And so anyway, if the hour is between like 10 a.m. all the way up, but not including 8 p.m., then they're open. And so then we get this check, zone switch, whatever. But this is if your shoes are shiny, I believe. So if your shoes aren't shiny, then whatever. Or if they're shiny, then you can enter. But okay. However, if it's one of these, if the time is one of these, then they're closed, and so it just says terribly sorry, the shop's closed. And then there's another one that's also very interesting. So Zel02, this is Kakariko. And we want to look at node 3F5. So wow, what the heck? What is going on here? So this is checking the Malomart shop entrance. Let's try to stretch these out so we can see better. Okay. So we enter here on the blue node. I'm not going to go through all of these, but okay. So here's an interesting one. If you've never been in there, yeah, entered Malomart for the first time. So if you haven't done that, then if they're closed and you check, it just says it's locked, which is interesting. Because if you check after you've already, is that the same text? Yeah. Once you know that it's Mallow in there, then the messages are different because, you know, when you first get there, you don't know that Mallow's running the shop. So you don't get the like sassy Malomart text. But once you know Mallow runs the shop, then you start getting the sassy text. So one thing that I saw while I was looking at this, which was pretty interesting. So 6 a.m. up until 8 p.m., those appear to be the hours that they're open. But if you show up right after they're closed until midnight, then it says we're closed for the day. And then if it's after midnight but before 5 a.m., then think, is there a reason for us to be open? No. which is kind of funny. However, I noticed this. I'm like, wow, I wonder how many people have actually seen this one or like realized that there were different ones. But specifically, if you show up at like 5 a.m. until 6 a.m., then it says we're not open yet, certainly not for impatient morning people. So I thought that was kind of interesting. But as you might expect, the num query results is 1.8, which would be 16 plus 8, which is 24 for the 24 hours. So you can see how that number lines up as you would expect on these. All right, now for the final float node type, it'll be an event node. And so the type byte at the very start is going to be 3 for events. Offset 1 will be the event index. As we looked at earlier. So that event index will be an index in the table here, which points to a function, which is actually a PTMF 12-byte thing. Okay. And then offset 2 is the next node table index. And so we looked at the next node table. Interestingly, let's see, if we click on an event node like this one, then we have a next node table index, right? So index 273, if we were to go there in the next node table, the value there is going to be 16 bytes, and it will tell us the index of the next flow node to go to, which in this case should be FFFF. So if we go to the next node table and we were to look at the value there, then the value would be FFFF. And so you might be wondering, if we're using 16 bytes to give an offset into a table where we're reading a 16-byte value, why do we not just store the 16-byte value directly on the flow node? So why would we not just store FFFF directly on the event node, which is what we do for message nodes, right? So if there's no next node for a message node, then we just store FFFF. And the answer is, I have no idea. That seems like it would have been easier, but it would have taken up less space also. But for whatever reason, that's not how it works. So event nodes, they have that same level of misdirection, I guess. But anyway, it's an offset in the next node table, and then you have to go and read that value from the next node table to actually know where to go. That's just how it works. Okay, and then the final 4 bytes are the event params, which are going to be used by the event function. So any additional data which can be used by the event function, a good example of this is when you're talking to Midna. Let's look at this one. So yeah, when we're talking to Midna, event index 9, so as event 009, that has to do with jumping to a different subgraph. And the event params in this case would be the FLI value, or the flow ID that we're jumping to. So if we look at FLI1, okay, and then you can see we have BCF as the event params. So let's look in this table until we see BCF, which is here, and that jumps to node 1AF. So if we go to 1AF, then that's actually how we get to this subgraph that we're looking at. So if we go back, so we were here, BCF. So you can see when we talk to Midna, and we're not in water, so we go this way, but we do have the shadow crystal, then we're going to jump here. And these are the menus that you're probably used to seeing when you talk to Midna. There's a check here about if you spun the AG pillars, if you cleared AG, otherwise it jumps to this other EDO subgraph. Anyway, so there's stuff there. Kind of interesting here, you have, are you wolf on a horse/boar, otherwise 0, so this would be if you're human. You're going to have transform into wolf menus. If you're wolf, then you're going to have transform into human menus. Or if you're like on Epona, then it's not going to show you the menu at all. Instead, it's going to jump to use event index 9 to jump to a different subgraph. And then if the event params is 0, then it'll go through this thing to resolve to whatever the talk to Midna text should be, because the subgraph that we jump to varies based on the game state. But we'll get into that later. But that's an example of an event param being used. Another one would be, as we showed earlier, when we run an event to subtract the price of the thing you bought, it needs to have the parameter say how many rupees to subtract. And so that's another example of an event param being used. Let's see. Also the event params, so it can be all 4 of them as an int, which is pretty common, or you can have 2 groups of U16s, which I will update these based on the event type to do a better job. But if we look at this one, for example, event, it's like 0000 and then 5. So it's actually 0005 followed by zeros. So here's an example of event index 8, where it's split into like 2 U16s. So the first one would be 5 and the second one would be 0. And this one, event index 8, has to do with, I believe that's setting 5 as the event ID and then whatever it is that was running this query. So I think the Midna actor in this case could look at that value. Okay, and here's an example of how those things are used in the decomp. So there's actually 3 different get param functions. And you can see there's like one where we're just reading the params as a single 4-byte integer and returning the value there. And then here is the this top one. This is where we're treating it as a U16, and then this one is where we're treating it as 4 bytes. So yeah, that's how that works in the code. Okay. Let's talk about the date 1 chunk now. So we find that. And you'll have the standard 8 bytes. So the name of the chunk and then the length how many bytes we have to jump to get to the next section. And then after that, it's all null terminated strings. So actually this one happens to be an empty string as the first entry in the table. I don't know if they're all like that, but anyway, as you can see over here, just a ton of strings, and that's literally all the date 1 section is. Yep. Okay, so first 8 bytes are the standard 8 bytes, which we saw. Null terminated strings, null terminated meaning the end of the string has a null character 00. Okay, and then the inf entries, which we'll look at, they have offsets stored in them, which are 4-byte integers, which are offsets relative to the start of the date 1 data after the header. So this will be offset 0. Here, this is not offset 0. This is offset 0. So this would be offset 1, 0, 2, 0, like that. Okay. All right, the next one to talk about are the inf entries. Each one of these is 1 4 bytes long, which is 20 decimal. So the very first 4 bytes are the string offset in the data chunk relative to the starting after the 8-byte header, and then offset 04 is the mid value, or I think I swapped over to calling this message ID in other places once I was confident that this was the message ID. But anyway, it's a value that shows up in the mid 1 chunk, which we'll look at that in a lot of detail in a second. But it essentially, the index at which we find that maps back to an inf entry, which really it just maps back to itself, but we'll talk about that. Oh, I literally said that here. So yeah, values are used in TP, but ultimately they always map back to the same inf entry. More on this later. So yeah, the mid section kind of pointless for the most part. Okay, so after these first 6 bytes, the rest of this, giving an exact definition of what every byte means is kind of out of the scope of this, because these aren't things that we're really going to be messing with from the rando perspective. And this would be, I would have to go in and like confirm all this stuff for like, anyway, it would be a bunch of work that this isn't really the appropriate time to do. But I can talk a little bit about what happens in the rest of these. So let's see, are we talking to min? Yeah, it's basically related to styling for the most part. There's also stuff like, as far as I can tell, the facial expression that should be going on, and the actor motion maybe is defined there. One of the most important things is the style of the text box, kind of. So like, is it a Midna text box, or is it just a normal one, or is it like a large sign like outside Giovanni's place? Should the text box be at the top of the screen or the bottom of the screen? I don't know. Maybe it can show up in the middle, I'm not sure. But that's what the rest of this inf stuff is defining. And I think we can pull up an example. So let's just kind of making this up. Let's look at this one. Don't you think you should leave town for a while? So how did I map flow node 185 to showing this text? Well, let's look at that right now. So flow 1, then I want to go to 185. Okay. So this 1, 5, F3, blah, blah, blah. You can see those values over here. So this one is pointing to this inf entry, which is 5F3. Actually, yeah, inf entries at the top. Its header is 10 bytes. So now we want to go to entry 5F3, and I'd have to jump 20 times to do that. So let's let me do the math. So 20 times 5F3. Okay, 76 FC. 76FC. Boom. Okay. So these 14 bytes right here, this is the inf entry. So 1F, these two 1Fs here, for example, are related to the what is it, the face num and the movement num? Something like that. But I think they're related to Midna, like doing the talking animation, maybe. This D byte, that is, I think it has to do, that's like the one that identifies this should be the talking to Midna style, I believe. But as you can see, there's like different stuff going on there. But the first 6 bytes are what we're concerned with. So 803 would be the message ID, which we'll go over in a second. But what we want to look at here is this 107DC. 107DC. Okay, so we jumped 107DC forward in, and we'll go until we hit a 0 byte. Wait, did I miss one? It's pretty long. Here we go. No, I guess that's right. So anyway, yeah, don't you think you should leave town for a while? I mean, at least until the upward settles, then you could come back. Yeah, with the 3 dots at the end. So anyway, that's how that inf entry 5F3 points to that actual string value. So now you know. All right, the final chunk we'll be talking about is the mid chunk, which I think is message ID. If you want the short version for TPR, what we'll be doing, basically you can ignore this section of the, or like this chunk of the BMG file. chunk, section, block, whatever. I kind of all use those interchangeably. Or the long version, we're going to go over on the next several slides. Okay, so this probably looks like a bunch of garbage. If you want to look through the decomp referencing this stuff, you can. I'm just going to probably read through this and then nod my head if I'm like, yeah, that I remember that. Okay, so D message flow C, set normal message, set select message, take the flow nodes, get the half words from offset 4 of the inf entries, which is the message ID. Pass these to FOP message manager message set. This internally calls set message index, passing the message IDs, which get stored on the message object instance. Yeah, this is a case where it's interesting. I believe I saw somewhere in the decomp that called the message ID values message index. Message index versus message ID is pretty confusing, but I believe message index is like the inf index, and then message ID is like the mid values. That's my understanding after like banging my head on this for quite a while. It's a bit confusing because you have set message index, but you pass in the message IDs, but internally to that function, it handles converting the message IDs into the inf indexes or the message index. So I guess maybe that's why it's named like that, but yeah, this stuff's fairly confusing. But anyway, message IDs get stored on the message object instance during its wait proc and continue proc. Call set message index with true bool param, which causes it to call set message ID on the jmessage control instance it points to. Internally, this function searches the midsection and finds the index at which the value matches, value being the message ID. Matches the normal message ID, the normal message ID, not the second select message ID. So for a select message, the normal message ID, I'm talking about the first box. So the first box, we have inf index BBBB. So if we were to L data, oops, refresh. Okay. BBB, or no, sorry, BBB, not BBBB. L data, BMG data, inf section entries. And then offset 4. In fact, I actually have that written as message index here because I haven't updated the names. It's very confusing. But anyway, 242, 2 string as hex, 7 FA. In fact, we can do one of those. 7 FA. So that's the message ID belonging to that inf entry. And we'll see 7 FA in a second. But okay. Index it with the midsection, which the match responds to an inf index, which gets passed to set message code in sequence. And if you recall, set message code in sequence, well, you don't recall from this presentation, but if you've messed with the message code in the randomizer project, which is probably like 1 or 2 other people, we're operating on the inf index and not the message ID, which is a large part of the reason that like this whole transformation that happens, we kind of can just ignore because the value just gets set back to itself before it even reaches our code. So anyway, so in set message code in sequence simply finds the inf entry directly by using the inf index param. So it would be like if the inf index is BBB, as we saw there, then we just, okay, inf table, and then look at the entry at that index. Okay, so here's some stuff I said that I confirmed. So set message code goes directly from the inf index to the entry. Get message index calls set message index search. Another calls. Search the inf section directly to find the entry where offset 4 matches the message ID rather than the midsection search, which sometimes use. JMessage T resource 2 message index message ID searches the midsection. It returns the index at which we find that offset 4 on the infantry. So anyway, all this is, what this is saying is that the message ID value is used in multiple different ways. One way it's used is that we search the mid section, which if we pull up what does the midsection even look like? Okay, I believe it's a 10 byte header, and then each of the entries is 4 bytes. This would be a message ID. So the index at which I find this message ID is going to line up with an inf entry. It's a way to map back. So like if let's say I'm looking for message ID 12, then, or we'll do message ID 5. So this is index 0, this is index 1, this is index 2, index 3, index 4. So I found message ID 5 at index 4. So it would map back from message ID 5 to inf index 4. So message ID 5 maps back to inf index 4. So that's one way that we map from a message ID to an inf entry. The other way is that sometimes certain code, instead of like even looking in this midsection, it will just look in the inf section. And so here's the first entry, they're 4 bytes. And offset 4, the 2 bytes there is a message, the message ID. So here it's 2 bytes, and that other one we saw it's 4 bytes, but I believe they're just 2 byte values. And so what we would do is, like, let's say we're looking for, we'll say message ID 3. So what we do is we look at the first inf entry, and then we read the bytes there. So it's 1, which is not equal. And then we do the next one, and we read the byte, and then that's 2, so that's not there. And then we read, okay, that's 3, so that does match. And so now that current one we're looking at is the one that we want. So it's used in multiple ways is the main takeaway. Okay, so here's an example of one way it's used. So when we read Link's house sign, which is in Zel 01 because that's Ordon, there's a parameter on the nameplate actor, object nameplate, which is 0192, and that's the flow ID. And then that flow ID, if we were to, let's see. Okay, so if we were to look at down here this is the FLI section, and we look for 192 right here. So 192 maps to node 467. So let's check that out here. So 467. So interestingly enough, this is a flow. The next node is nothing because it's only one node in the flow. And it's just player names house. This is a tag, which we'll talk about later, but it gets substituted in for whatever the players set their name to be. Okay, but anyway, so the flow ID maps to that 467 flow index, and then the node at this has inf index 658. So inf index 658. And then the message ID at offset 4 of inf entry 658 is 232D. So let's confirm that. L data BMG data inf section entries 658. And then offset 4, sorry, this should say message ID. 9005 to string, okay, 232D. Okay, so message ID at offset 4 is 232D. This gets stored on the message object. Okay, during execution, the mid section is searched for this value, and the index within the mid section that we find 232D is at index 658. So if we go to mid 1, and then starting here, we're going to go forward 658. Each entry is 4, so we'll go forward 658 4 times. 1, 2, 3, 4. Okay, so we're in, this is index 658 within the midsection. The value here is 232D. So as we scanned through stuff, we found it at this index 658. So what we ended up doing was going from inf 658, and then that was transformed into this 232D message ID, and then that got transformed back to the exact same value. So kind of we can ignore the message ID because the inf index is always going to map back to itself, other than this one exception. And I determined this by looking at, every file, every language, every region. The only exception this happens, or this where it doesn't map back, is in Zel 04, which we can look at. In fact, that's what this is: no non-matching inf index after doing blah, blah, blah. However, for Zel 04, the only non-matching was 646. Okay. So here's the exception. In Zel 04, which is for Castletown, infantry 646 has a message ID of 177F. This message ID is found in the midsection at index 265, which means it maps back to infantry 265. I'm assuming... Yeah, I'm assuming the scan would find it that way. In any case, infantry 265 is only used by flow node 71A. And what we can do is look at flow node 71A this way. So ldata.bmgdata.flow section.entries 71A. Then we'll do 613. So 265. So that one, the inf index it points to is 265. And then if we were to go to that infantry and then look at the string it points to in the data section, it would be this string. However, that infantry 646, as you recall, there are some inf entries that are not actually used by flow nodes. For example, the TV settings one, where we just have the string TV settings, that is that's an inf entry which points to a string, but it's not actually used by a flow node, which means it's not part of a message flow. And this one's the same way. So that is to say this whole, if you recall, the mid section is not used in the direct string lookup. What are we on? 33. So the mid section is only used in the context of a message flow. It's not used for the direct string lookup. So the fact that this one is infantry is not used by a flow node, which means it's not part of a message flow, means this whole the fact that this exception even exists probably doesn't even matter. So anyway, we can keep this one in mind, but what this means is that we can basically, especially for TPR, basically ignore the midsection. But I think we still have some more stuff to go over with it. Okay. So here is, later on, I found some more spots where I'm like, oh, this is the message ID. And this is why I was pretty confident in calling it message ID, is because I found these spots in the code where we had get message ID, which I'm assuming is correct. That probably came from the map files or something like that. Anyway, and it's pointing to these values. I'm like, 7FA, I've seen that a million times. I know exactly what that is. Because 7FA, as we looked at earlier, was this very common when you have Shadow Crystal and you're talking to Midna and the menu shows up. So as I was messing with this stuff forever, I've seen 7FA a million times, but anyway. Okay, so, and this, remember how I said the D value, where it was hex D, which is 13, was related to Midna stuff? I think that's where that's used, or an example of one place where that's used. But anyway, so the message ID, we have these different message IDs, and this is a Boolean function that returns a Boolean for if it's a Midna message. Yeah, so in the dMessageObject_C class, there's a handful of places where message IDs are hard-coded, and in fact, they're even called message IDs, which is why I'm pretty confident in calling them message IDs. Okay, so let's look at what's going on here. So message ID 7FA is found on inf entry BBB, which is used by this one. And then it's found on these flow nodes. So an inf entry can be used by multiple flow nodes. These are the text box message nodes for the 3-option transform, warp, or talk menus. And in fact, it would be transform into wolf specifically, maybe. Anyway, and then we also have that 7F6 is found on the inf entry A2C, and inf entry A2C is found on flow nodes 1 and 3. And this is the text box for the warp talk from the pre-Hyrule barrier appearing. So this would be pre-Hyrule, so that's here. Is that right? Warp talk. Yeah, I think it's this one. That's inf A2D. And I said A2C. A2D. Oh no, A2C, sorry. A2C is found on flow node 13. Oh yeah, sorry. Text box message node. So what I mean by text box is the box at the bottom of the screen. For the 2-option warp talk. Okay. Oh yeah, and that's the text box. Yeah, sorry. So it's the text box I'm looking at, not the options node, the text box node, which is what we were doing over here. This is the text box node at the bottom of the screen. Okay, yeah. And then we have 7D3 found on inf 5DE, which is used by all these flow nodes. And that's the bottom text box and message node for the transform talk menus. Except flow entries 6 is the warp talk to Midna from the post Hyrule barrier and before getting the shadow crystal. Which is this one. Anyway, so, okay. So yeah, those are, if you see what's the shared thing between them, these are all the messages when you're talking to Midna. Those are all the locations. And so that's how the, in fact, we can go to the D message object is Midna message. Here's where it came from. Yeah, so if the message ID is currently one of those things, which means you're talking to Midna with that menu showing up, then the is Midna message returns true. So that's one place where message ID is used. Some other message ID uses. So Z2 get audio manager change BGM status, as in background music, not BMG. So we have some C73, which is only used in cell 00, which is the case for all these, found on infantry 89E, which is not found on any flow nodes, which is the case for all of these. But okay. So the text that infantry points to, but enough about that. Do you hear that noise? That's the lamentation of the spirit that had its light stolen, which I think maybe shows up in a cutscene. I'm guessing. But anyway, change BGM status and then like, do you hear that noise? So that kind of checks out. And then here's a different one. And then, yeah, both of these. Yeah, anyway, when you're first talking to Midna, you're going up to Zelda, I believe. So that's change BGM status to, and then the tag appears to call message SE play, which I think is sound effect. This 1014. Okay, anyway, so that's one place where we're checking against a message ID. And then here's another one. In the talk start init function, we use new message screen item C rather than new dmessage screen talk C or message ID 2A5. Oh yeah, okay. So this is, yeah, this took forever to type out. But this is a, when you get the Gale Boomerang. And I believe this is why, if you know, instant text function, how it's like this one thing it works really weird on. I think maybe this is related. But in any case, if the message ID is this specific one about the boomerang, then we'll use that to do a message screen item rather than a message screen talk, I guess. Oh yeah, and also this 1A0903C65 appears to be reference P set revo message ID. Yeah, there's also this revo message ID message index stuff, which so we passed the C65 as that pointer in there. And yeah, as I say here, that's another can of worms, which I haven't looked into. Reference P is a JMessage reference pointer, which is probably stored on one of the, probably the one stored as a member on the dMessage object C. Oh, okay, yeah. Yeah, the dMessage object C has a JMessage reference, which I think is what that MP refers. Anyway, but yeah, that's a whole other can of worms. So yeah, in conclusion, the mid section is confusing. No, I didn't actually write that here. Okay, but yeah, perhaps it's the case that the message IDs or the mid values are considered stable, and the inf indexes or the message indexes are not. My reasoning for that is that the message IDs are actually quite literally hard-coded into the freaking code, which would imply they're stable, I guess. So maybe that's the point of a message ID, that the message ID is a stable thing and the inf isn't. Or I guess actually you could have two things. Well, no. Yeah, I don't know. Yeah, but anyway, so we can keep all this info in mind about message IDs, you know, just to keep it in mind. But from the perspective of TPR, where we're making specific changes to stuff, you know, to give us the rando behavior we want, the mid section, you can kind of just throw it in the trash can and forget about it. The flow nodes and the inf entries are the main ones we care about. Also, I mentioned this earlier, but I'm pretty sure the message IDs, the mid values, which are at offset 4 on the inf entries, and then message index, I'm pretty sure that's the index of an inf entry. But that's as far as I can tell after, you know, banging my head on this stuff. Okay, so we're about to finally get into the, you know, what code have I written to mess with this stuff for the rando stuff, but I recalled, I wasn't sure if I called this out, and I just wanted to go back here to call this out. I think I go to it in more of a later section, so I'll probably repeat this, but I definitely wanted to mention it. I think I've seen some stuff where it said the flow ID was like an unsigned byte. However, it's very important to understand that the flow ID is treated in a signed matter. So here I wrote it as an S16 because it's used as an S, like a signed value in places that matter. So I think later on we'll go over this, but if we have a flow ID, then how do we know if it's global versus coming from the local stage file? For example, zel_01.bmg, which is used for ordon, versus zel_00.bmg, which is the global one. And the way you know if the flow ID is global or local is that if the flow ID is greater than or equal to 3000, which is BB8, then we're going to use the global file. Otherwise, it will be the local stage BMG file, which would be numbers 1 through 8. And then even if technically the value might be considered unsigned, even though I would consider it signed, the above comparison treats it as a signed value. So I would suggest thinking of it as signed. So kind of the maximum value is 7FFF, which we'll hopefully talk about later, but I definitely wanted to call that out before we move on to this next section. All right, coming back after another break, so hopefully the voice isn't too different, but now that we've talked about the BMG format and how that stuff works quite a bit. We should have a pretty decent understanding of what's going on there. So we're actually finally ready to talk about what is going on with this new system, or the code for adjusting this stuff. So anyway, let's get into that. Okay, so here's our supported types of patching. The first is remapping a node. So if we're about to go to node A, instead we can go to node B, and we can also set context, which is something I'll go over in a second. An example of this is when we are going to the talk to Midna code, we can instead send it over to our new custom menu code. So that's an example. For setting context, that's also important, but we'll get to that in a second. Branch patches, this would be if we had an existing branch node that we wanted to adjust something about. We can adjust, of the 8 bytes, we can adjust any of the 7 after the first one. And we'll talk about how that works. Essentially, if it's already a branch node, we're not changing the type of the branch node. Okay, we can also handle the branch next nodes. This is handling the results of the branch results, basically controlling what nodes those send us to. Event patch. So yeah, the event patch, event next node, those are basically the same. At a code level, we kind of have to hook into different locations, which is why they're handled differently. And also just to avoid potential mistakes where we're on a branch node when we mean to be on an event, and so on. And then the final thing we can do is replace strings, and this works for within message flows and also for your string replacement outside of message flows, for example, where we set the seed name on the TV settings screen so that when people are like sitting on that before a race starts, for example, we can more easily or have a higher likelihood of someone spotting like, oh, that person's on the wrong seat or something like that. But yeah, these are the currently supported types of patching. It's things are set up to where we could add more. Like if we ever got to a point where we needed to mess with inf entries, for example, outside of a static context. But for now, oh, and it scales well. I don't know if I said that already, but it yeah, I put a lot of time into getting the code size small for this and having it where it scales well. Okay. So another thing that comes out of this effort is custom query and event functions, which is pretty cool. So as we've seen, a branch node will run a query function, which can take params. And we have the ability to add completely brand new query functions. And the query functions are U16, so we're basically unlimited. And some examples of the custom queries I went ahead and added. So I put one where we basically set the parameter to where we can force it to always branch exactly the same way. So it's kind of a way to skip over a query or a branch. It's sort of like a NOP or like no operation equivalent of the event node one. And then there's a can change time of day query, which we have to use to know if they can actually change time of day. So when we're seeing, should we show the change time of day and hints menu, or should we just show the hints text because they can't actually change time of day? So that's where that's used. Additionally, we have custom event functions. So the event index is a U8, but using the params, you can also get quite a lot of event functions. So that they're kind of unlimited as well. But there's a few custom events. So there's a NOP event, which is there so that we can easily disable an event node. So if there's an event node that we just want to completely just kind of paint over it so it doesn't do anything, we can do that pretty easily. There's also a change time of day event, which it's a new event used in our custom Midna flow for changing time of days. So when we make it to that node, we proc our change time of day code based on the event index. And then there's a third one. This is the only place this is used is for that quiz sign demo in order to give an ice trap. So we probably might not actually need it, but yeah, it's one that adds an item ID to the queue. And you might think we don't need that because you have things such as like when you're first talking to Uli early in the game, you know, she gives you a fishing rod, and how does that work? But if I recall, the code to handle like giving the item, it's more of like event index 8 setting an event ID, and then the control goes back to the Uli NPC actor, which actually handles giving you the item and then resuming back into a flow after that. So it's not that whole thing is not as simple as you might think. So purely by modifying the message flows, which is what we're doing here, that's not super possible, which is why we're using this new function here. But that one potentially can be removed before you make the PR because it's only there for that one demo. But anyway, those are examples of things we can do. Okay, the final one to mention is a flow context, or sometimes I'll just call it context. So this is the system for how we can reuse existing nodes under different contexts, and then that way we can treat them as custom. So as I'm sure you're aware, we don't modify the ISO directly in the same way that pretty much every other randomizer does. So for creating the custom Midna flow, it's not as simple as just taking the BMG file and editing it so that everything works exactly how we want. We kind of have to we have to be fancier with our patching. And so the context is how we can do this. So for example, the change time of day and hints menu, we're reusing existing nodes, but the context lets us know, it's like, oh, this node under this context, so we need to replace the menu text with change time of day and hints, for example. And we'll go over some examples of this also. So the default context is 0, meaning no context, and as we'll see when we talk about comparisons, the context-related comparisons get skipped over whenever context is 0, which means 99% of the time we're skipping over any sort of context comparisons, which is to say, we'll talk about comparisons, but it's all very efficient, and we only do like as little work as possible. And we do it as quickly as possible and try to break out early. So yeah, I've definitely put a bunch of time into trying to get the code size small and the data size small, and you know, have it run as few instructions as necessary. But yeah, the context gets reset to 0 whenever a flow ends or whenever the flow ID changes, which is just to clean up after ourselves and make sure we're not doing some freak, you know, the flow ID changed and now things are kind of broken. So, and the context is treated globally. It's stored on the randomizer object, I believe. And that's because there's only ever one message flow at a time, which makes sense, right? There's no, like, you're not having a conversation with like 2 conversations at a time. A lot of the message object interactions while you're in a message flow are handled statically as well, because they're accessing like the static message object that's the representative of the current flow. So all of this it happens at a one at a time kind of way, which is why it's safe to only have, or basically why it's safe to have the one context handled globally. So okay, so let's talk about how these adjustments actually work. So if we want to make an adjustment, we need 2 things. The first thing we need is the data corresponding to the adjustment we actually want to make. So if we are trying to replace a string with a new string, then obviously we'll need the new string data in our GCI for the seed. Or if we have a branch patch, then we need to know which bytes are we patching and what values are we writing there. So we need the data for the actual adjustment. And then the other thing we need is comparison data to know when to actually apply those adjustments, right? So, if we have a string of the seed name, then we have to know, is it loading, the string on the TV settings screen in order to replace it? Because we don't want to replace the wrong string. Talking to Midna, we don't just want to randomly say the seed name. And so there's a few different ways, or a couple of different comparisons that we have going on, which I think we'll go over in the upcoming slides, but let me just read through these examples. So if we want to change the price of the slingshot to 55 rupees, then we need to adjust the param on the can you afford it branch node from 30 to 55 so that it compares your current rupees against the correct value, but we only want to apply this patch to the specific node, right? Yeah, so we need to know, we'll have this branch patch that says, okay, change the parameter to 55, but obviously we only want to do that for this specific node. So we need to know if we're looking at the correct node. And then, the change time of day and hints menu, we need to know, are we operating on the correct node in context? Because maybe those nodes, like if they're being used in the vanilla way, then we don't want to mess with them. But if the context is set up so that we should use the change time of day text, then we want that to work. Okay, so how do entity comparisons work? And when I say entity on this stuff, I'm talking about like the node remap, the branch patch, branch next node, event patch, event next node, string replacement. Those are each different entity types, because the entities being the data kind of. But anyway, that's the name I'm using for them. But okay, so entity type plus BMG number. So that's the first thing that we check. So let's say entity type is a string replacement and the BMG number is like 7. And worth mentioning, previously string replacements have kind of been done on a stage or room basis. But since we kind of know more how the BMG files are set up, now we can still write things in like a stage basis, but like within the generator code, but they get translated to the BMG numbers, so like 0 through 8, when we write them into the CGCI data. And so that way it's more like we're directly modifying the files themselves. But also only having 0 through 8 makes it where it's a lot easier to, it's like a smaller amount of data we need in order to jump to the correct places. But okay, so we have a bit flag to know if we have any data for this, and context version and non-context versions get their own bit flag. Otherwise, we'll get a range and a comparison table to search. This is handled by the BMG file and not stage, like I mentioned. We can still reference the stage in the generator code. Okay, yeah, I kind of just said that. So for example, if we say, okay, we're making an adjustment to Malomart price stuff, and we just say, okay, Kakariko Village interiors. Well, that's probably easier to say and maintain in the generator code, but it'll get translated into BMG2 is what we're modifying whenever it actually writes out the CGCI. So that's kind of what's going on there. And just as an example, so if the entity type is, let's say, an event node byte patch and BMG 7, then if that doesn't have any data, then we'll have like the bit for that will just be set to 0. And so we can like very quickly see there's nothing there, and we skip just a ton of other code that might have to execute otherwise. Okay, so in terms of the comparisons, the very first thing we'll do is try to check from a context perspective. So if the context is not 0, which meaning there's actually an active context, then we'll use a context comparison value, which is what conf_val is. And so it'll be a U32, so 16 bits of context, context being a U16, and then the 16 bits of the flow index. And in fact, it could be like an inf index for different things, yeah, which we write down here. But it'll basically be the entry index plus the context. And so we'll compare as a U32. So if the context comparison didn't find a match, then we'll try to find just a normal comparison value, which would be without the context. So the normal comparison value would be a U16, which would be the 16 bits of the flow index or the inf index for string replacements. And then for node remaps only, the normal comp val is also 32 bits, so it would be the 16-bit FLI value, which is the flow ID plus the flow index. And that's because there are situations like the custom signs. The custom signs will have a flow ID, and then the flow index will be FFFF for all of them because they're not real, in quotation marks, they're not real flow IDs. They're fake flow IDs that we're using, which means when the vanilla code runs, it will have the fake flow ID, which will always not find a flow index to start at, which means it'll be FFFF. And so we need to factor the FFFF along with the flow ID in order to identify the custom sign we're reading. So anyway, it's a bit of a special case there, but yeah. So I think, well, anyway, we'll talk more about comparisons. Okay, so here's an example for a custom hint sign. And so we use FLI values or flow IDs for custom hint signs that are 7000 and up. The highest normal flow ID is like less than 2000. So we have just like an absurd number of flow IDs to work with. But I have things set up currently to where 7000 hex and up is for custom hint signs. So the Ordon sign, so it has that flow index of 72B0. And I mentioned this near the very start of the, like back in the demo, but in order to reduce code size, when we're setting up the custom signs, we're using a pattern to pick the flow ID where we use the stage index. So we use the 7 to start so that we're guaranteed to be above 7,000 hex. And we take the stage index of the stage number, shift it over 4 bits, and then, so that's how we get 2B, for example, would be the stage index for Ordon Village. Then, if we have more than one sign per stage, we can OR a value with the last 4 bits in order to handle stages that have multiple signs. So for example, Eldenfield 7380, Barren Field 7381, Kakariko Gorge 7382, for example. So 38 would be stage index for Hyrule Field stage. And then since there are multiple, we can apply an extra OR. And so this is so that we only have the one instruction for every stage, and then it's only in the case that we have multiple stages or multiple signs per stage that we need another instruction in order to finalize the flow ID. Okay, so when we try to read the sign, like a custom sign, the game will read through Zel00 BMG's FLI entries to try to find a match for the flow ID, which it won't. So since there's no matching flow ID, the game tries to set the node to FFFF. Node it searches Zel, not the stage. Yeah, because our FLI value, or the flow ID, is greater than or equal to 3000. Completely custom flows are handled with large FLI values, so they always use Zel00 in order to make things easy. And note this is a sign comparison, so the max is 7FFF, which we have mentioned before as well. Okay, so continuing. So what we have is this flow ID, or FLI value, and the flow node is going to be this. So when the code is about to set the node, the node index to be this, which is going to start triggering some like ending the flow code, we instead, and when there's no context. So what we want to do is, okay, there's no context, like they're setting the node, there's no context, this is the FLI value, and this is the flow node. Then what we want to do is change the flow node to be this one and set a context. So for example, maybe the context is 4. And then now we're on node 4D, and then we have a string replacement on node 4D when the context is 4 to show our custom text rather than the vanilla text for node 4D. And if we don't try to remap the node again, node 4D naturally has FFFF as its next node, so the message flow will end. So you could imagine this is the ordon sign, and it has a single hint on it. But if we have multiple hints on that ordon sign, for example, then what we can do is keep looping back to 4D and updating the context. So I think I show this on the next slide. Okay, so if we have no context and we're on this FLI with this flow node, then we map to 4D and set the context to 4, for example. And then if we have 4 context and we're trying to go to FFFF, then we can map back to 4D as the node and set the context to 5. And so down here, when the context was 4 and we were on node 4D, they said that iron boots are in Goron mines, for example. And then what we did was we mapped back to the same node but set the context to 5. And now we're on that node with context 5, and we say there's nothing in Zor's domain. And now that we're on 5 as the context and we're trying to end the flow, then we say we're not actually done yet. So we go back to that same node and set the context to 6. And so then we say context 6, and we're on this node, means they say that Bo has an orange rupee. And then now there's no more node remaps, which means we're on 4D, and then the next node is FFFF, so the flow just ends. Hopefully it's not too confusing. But yeah, this way we're able to essentially do infinite nodes for a single flow. Okay, I talked a bit about the comparisons earlier, which may have been a bit confusing. So we're going to talk more about them now. So there are 2 different comparison tables. One is a comparison table for U32s, and the other is for U16s. And we combine the tables that different entities use in order to simplify and reuse the comparison code. So for example, rather than have, like if we look here at, so an entity adjustment, we need the data for the adjustment to make, but it can be variable length, right? And we also need especially like between entities, and we also need the comparison, but the comparison size is basically going to be the same between different things. It'll either be a U16 or U32. So if I was trying to do like a branch patch one, the actual data is 8 bytes, and the comparison could be 32 bytes or 16 bytes. So that's like 2 tables for a branch patch. And then if we went to like the branch results one, we would need those same 2 tables, and then its actual data size is variable length. And if we, we have 6 different ones, so it just simplifies things a lot in order to kind of combine the comparison code to where it's like just using these same tables. And so what we end up with is we just, rather than having like 2 tables per type, we just kind of have 2 general tables. And then the comparisons are done within those singular tables. And so that cuts down on, or it simplifies things, and it also cuts down on the amount of code we need in order to actually search for these comp vals. Okay, so when we're doing a context compare, we have a comp val, which is a U32 comparison value. First 16 bits are the context, and the next 16 bits are the entry index, which would be an inf index or a flow index, depending on the entity type. And for a normal compare, the comparison value is a U16, except for node remaps, which is a U32, because we need the flow index and the flow node. Or sorry, the flow ID and the flow node. And then something else to mention, these tables are optimized to have a binary search, which is actually, I was surprised, but it's like a tiny, like the world's tiniest algorithm. So it doesn't take up a lot of instructions. But okay, when we're searching a range in the table, the comparison values are ordered, so we use a binary search, which is nice. And then the index at which we find a match, if we do find a match, has an adjustment value added to it, giving us the final index in the entity table. Okay, yeah, I wasn't sure how much detail I wanted to go into with this, but I feel like having tried to talk about it. I feel like what I've said so far has been very confusing. So I did want to go ahead and try to go into a little more detail, actually looking at the contents of a CGCI. So we have, if you look here, we have the BMG 0, which is the start of this section in the seed data. The header is 3.8 bytes long. And so now if we look here, we're looking at, or this is the data for checking if we have specific BMG file, if we have data or not. So the way these are broken up is 4 bytes for context and then 4 bytes for the non-context version per entity. So this would be right here. This would be entity type 0, which is a node remap. This is entity type 1, which is the branch patch. Entity type 2, which is the branch next node. Entity type 3, which is event patch. Entity type 4, which is the event next node. And then entity type 5, which is the string replacement type. So these, so 3 0 bytes, so 8 bytes per type. And this is how we can find if we have BMG data for these things. And if assuming we do have data, it's how we find the start index as well as the length of the sub array within a comparison table in order to search for the comparison values. So yeah, we'll walk through an example here. It's a bit complex. Well, it's not so complex, but it's like designed in order to make the size as small as possible. And anyway, my point is we're a bit in the weeds here, but we'll go ahead and continue with an example. Okay, so the one I want to look at is the branch patch that I currently have on the Sarah Slingshot branch. When you talk to her and try to buy the Slingshot, where we're patching that branch node to check whether or not you can afford it, to check against 55 rupees instead of 30. So that's the first one we're going to look at. So the branch patch entity type, that's 1 is the value there. And so that means we're looking at these 8 bytes. So the upper 4 is for context. I know that for a branch type, or sorry, for this specific one, this is not handled under context. This is just handled normally, which is what this one is. And so the if we look at the second U16 here, the rightmost bits, it's a 9-bit bit field, or like flags, starting from the right. So the very first, this value is 2, for example. So the very first bit, which would be for BMG 0, is not set, which means we don't have any normal branch patches for BMG 0. The next one, which would make this value 2 for BMG 1, is set. And that's how we know, okay, we do actually have normal, like non-context branch patches for BMG 1. But okay, so now what we do is we ignore the bottom 9 bits. We're going to look at the top 7 bits. So let me bring that up. Okay, we want to look at the top 7 bits of this 0A02 value. So if we do 0A02 and shift 9, then we end up with 5. And so 5 is the base index. So immediately following these, we're going to have these like a start value in a table followed by a length. And so we'll start at index 5. So this will be 0. This is 4. And so this is index 5. And so we're going to count up the basically index 5 is sort of the start one for this. And so BMG 0 doesn't have one of these defined, therefore it's not BMG 0. However, BMG 1 does have one defined, so this one is BMG 1. Essentially, we only defined a start index and a length for the comparisons for context plus entity type plus BMG if it actually exists. Otherwise, we would have just a very large number of these where the length is 0. Like it would be going off the screen. It's like multiple 100 bytes. And so we only actually define these ranges when the length is not 0, just to save a bunch of space. So even the code, the extra code in order to do these transformations, we more than make up for how much space we save by not defining these lookup start index and lengths for every single possible context and entity type and BMG number. And I think I go into more detail in upcoming slides about how exactly saving the space there works. Okay, so we'll go ahead and keep going here. Okay, so what we're actually looking at here is offset 0 in the comparison table, and there's only one value in our subarray that we're looking at. And we know that since we're operating on a basic one and not a context one like this one, that and since it's not a node remap, we're looking at the U16 comparison table. So if we go to the BMG, the start of the header, we know that offset A in the header, so right here, and it's a U16. So offset 284 relative to just the start of everything is the U16 comparison table. So if we go forward, what did I say? 284x. Okay, so this is the start of the comparison table for U16s. And so we know that within this comparison table, we said we start at index 0 and the length is 1. So this is actually the only possible comparison value. For other things, perhaps there would be more. Like if we had multiple normal branch patches in BMG 1, which might happen if we ever hit a point where we had randomized shop prices and more than that one slot in Sarah's shop was adjusted with a branch patch, then our length, instead of being length 1, we might actually have multiple values here. But in the context of a branch patch, if we go to Zel 01, 4CA is going to be the node or the flow index that we're looking at. And so what essentially we're doing here is we're saying, is the current flow index, is that 4CA? And so you can see this is the one we're changing, right? The current rupees. We want to do a patch to change this. And so only if the current flow index is 4CA and there's no context and we're operating in BMG 1, are we going to apply this patch. So in this case, we did find a match, and it was at position 0 within the table. Let me just double check. Yeah, so we found the match at position 0 in the U16 comparison table. And then what we have to do is add the first 2 bytes, which are the adjustment value. So this is to adjust that to be a finalized index within the actual entity table for branch patches, which I know probably sounds confusing. But let's go ahead and jump to the branch patch table offset, which is E. So 3D0 right here. So we want to go 3D0 from our current offset. Okay. And then offset 2 within that table is here. So this is a one branch patch. There's a different branch patch. And then this is the offset 2 branch patch. And as you can see, the way these ones work is the first byte is like the magic byte. And then the remaining 7, as long as the byte doesn't match whatever the magic byte is, then we make that change. And so here at offset 4, we're changing it to 0037. So offset 4 is the query params. And if we were to do hex 37, then that's 55. And so that's how we know, okay, we're at the correct node and we want to apply this patch before we process it. And note that these patches are not handled statically. So basically we make a copy of the node, apply the patch to our copy, and we're always passing our copy into the actual function that's like procking on the branch node. Because if we're like operating under context, for example, where we're operating on nodes that aren't real, then when we apply a patch to a node, like we don't actually want to mutate the existing BMG data. So yeah, that's just something to keep in mind. So I know that seemed probably pretty convoluted, but yeah, it's all in the name of saving space. Yeah, I guess you'd have to look at the code, but it's efficient, I guess. Though I admit it is a bit confusing. But okay, so I did want to just show one example of how that works. We are kind of in the weeds here, but I was kind of getting the feeling that just like talking about this at like a general level probably wasn't getting across what exactly was happening. So I did want to show that example, which is, anyway, hopefully it's not too confusing. We're going to move on. This part isn't necessarily the most important part of the presentation, which is funny because it's the part that might be relevant for the PR, though I kind of feel like arguably the just more general knowledge stuff might be more important. But anyway, that's just me apologizing for not being able to give a very good explanation. But okay, we'll go ahead and move on to the next slide. Okay, we can talk about a string replacement example. I'll just quickly go through this. So if we want, let's say we wanted to actually replace the TV setting string with ABC, then how does this work at the code level? So the string that we're replacing is in zel00 BMG number 0. The inf index is 55b, and this is just like a non-context kind of change. You wouldn't, like there's context only exists within flows, like flow context. So just direct string lookups like this will never have anything to do with context. So anyway, the comp val is simply going to be 055b. And so then in the code, when we're trying to determine the string pointer for that like set message code and sequence kind of thing, we're going to check a few things. So the first one is, are we actually operating inside of BMG 0, so zel00? Because if it's like, if we're looking up a string within zel01, then we don't care about this at all. And then assuming we are within the correct BMG file, is the inf index that we're operating on the one that we care about? So only if both of those match do we actually want to go in and like adjust the string or the character pointer to point to our new, our custom string. Okay, so how do we know which BMG file we're operating on? So if we are within a flow, we can just look at the FLI value or the flow ID. And so if the flow ID is greater than or equal to 3000, which is BB8X, then that means our current flow is within the zel00 BMG file. And if it's not within zel00, then it's very trivial and fast to check what the current stage byte is. We can look at the code where it loads the BMG files in order to see how they find the byte value to map to the BMG file name. And it's actually very simple because like 4 means Zelo4. So it's just a read the offset on this object, which gives us a pointer to this object, read this offset on the object, which gives us a pointer to the next object, and then read offset whatever, read the byte there in order to get whatever the BMG number is. So it's like very trivial. In fact, I think the function might be inlined. Maybe it's not. Anyway, but it is trivial. It's like, oh, it's not 0. Okay, well, what's the number? That's trivial to find. Okay, but if we are operating on a string replacement, then obviously that does not happen in the context of a flow, because the strings that we're replacing don't necessarily happen within the context of a flow, which means we don't have access to whatever the flow ID is, because there might not even be a flow ID. But fortunately, we do have access to the current inf block of the BMG file that we're operating on. And so what we can do is do a global search for the zel00 BMG file. And then once we have that file, we also have its inf block. And then we can just compare, is the address of the inf block that we're currently operating on equal to the zel00 inf block address? And if they are the same address, then the one we're operating on is obviously zel00. Otherwise, then we do that same lookup to find whatever the byte value is. Okay, so I did already go into a bit of detail about this when we looked at that in the weeds example. But this is basically talking about why the lookups are the way they are. And it has to do with optimizing data size and comparisons. So the range definition was the thing I showed where it's 2 bytes for a start index and 2 bytes for a length within a comparison table. So that's 32 bytes or 4 bit, or okay, sorry about that. So yeah, it's 32 bits or 4 bytes. So if we had a range definition for every single possible thing that we could replace, we have context versus non-context. We also have the entity type. We also have the BMG number, and then the 4 byte size. So if we do that, there's context and non-context. That's 2 ways. We have 6 entity types. There are 9 BMG numbers. And then it's 4 bytes, so that's 432 bytes or 1B0, which is quite a lot of data, at least for this. So the vast majority of these actually have no data, as we saw. Like if we look here, these are the actual range definitions. So we have like 1, 2, 3, 4, 16, 18. So we only actually have 18 different things in here for the comparisons. Which is obviously a fraction of the total that we could possibly have. So we save a lot of space. Out of these 432 bytes, we're only using, 18 times 4? So just like a tiny fraction of that. Yeah, so the vast majority have no data. So storing all of those ranges is a bunch of wasted space. And so, yeah, there's been multiple iterations on this. In fact, the latest one, I was like laying down, trying to go to sleep, and then my brain was working on this. So anyway, I ended up having to get up and write a bunch of stuff down. So, okay. So imagine a case for branch patches where we only have data for zel00 with context, non-context zel2 and zel4, which is not that far away from the current reality. So ideally, we only store the range data for these 3 things, and we don't use up space for the other 15 ones, which don't need to be there. And 15, so we have 3 plus 15 would be 18, which is to say context and non-context versions for all 9 BMG files. So here we only have 3 instead of having 18. Otherwise, we'd waste another 3C bytes just for this one entity type, and there are 6 entity types, so you can see how we would end up wasting a bunch of space. So the assumption is that most of these combinations of the context, no context, plus entity type plus BMG number will not have any entity adjustments defined. And so we can save space by only storing the necessary range data. And this is in fact true because if we look, right now we only have these defined in about 15% of cases for this. And so there is a code size cost for in order to save this data space, but since we're using so little of the data space, that even with the slight code size that is added, it actually saves a bunch of space still. Let's see. Currently, this does save a fair bit of space, and it scales really well if we were to add another, like a 7th or more than 7. Okay. Okay, so this is the structure I showed when we went through that example. So yeah, for each one, we have the 4-byte structure, the first 2 bytes being the adjustment value to map the relative index at which we found it within the comparison table to the final index within the entity table. And then we also have bit flags to very quickly see, do we even need to, do we even have data for this BMG number? Yeah, here's an example. The first entity in the branch patch table has index 0, but maybe the comparison value match is found at index 17 of the comparison value, or comparison table. So the adjustment value would be -17. So we find it in the comparison table at index 17, and so we add the -17 to get 0, and then 0 is the final index within the actual branch patch entity table. But yeah. And yeah, we did skip over a little bit of the like very, very low level details. But you can look in the code if you are interested in like exactly how everything works. But yeah, just to look at the byte size we're saving. So if n is the number of entity types, then p is like the portion of the fraction of the context or non-context plus entity type plus BMG number that's used. It's like the proportion between 0 and 1. Then instead of using 2 times 9 times 4 times entity types plus an additional, we would still need an adjustment value. I believe that's what that is, yeah. So we would use 76 times n bytes. Yeah, 2 bytes for the adjustment value for, yeah, context and non-context. So instead what we do is we use the 8 bytes times the number of entities, which was the BMG, so this 8 bytes times the 6 entities. And then we only use the 4 bytes plus this overhead of about 104 extra code bytes, which is like 26 instructions-ish. So we end up with this formula based on P. And so for low values of P, this uses less space, and they don't even up until about 70% usage, which we're not expected to reach. And as we talked about earlier, we're using about 15%, which puts us down here. So this is for 6 entity types. So if we weren't doing this, this way of saving space, then we'd actually be all the way up here at 400 and something bytes. But we're actually down here at like just over 200. So yeah, less than half of the space usage. And then yeah, if we were to if we add more entity types, then it saves even more space. Yeah, even if we were to somehow reduce the entity types, then we're still saving space. So yeah, just wanted to take some time to talk about that, I guess. Okay, now let's talk about string deduplication. So when a comparison matches, we end up with an index and a table of entities of fixed size. So for a branch patch, we saw that the entities were 8 bytes. So like that was down here, for example. So the entity, this being the entity table, the entries within the table are 8 bytes, right? So we have to end up with an index for a table where the entries are fixed size, but for string replacements, the strings actually have variable length. So instead what we need to do is end up at we store the strings in a string table, and then we get an offset index in the table of offsets for the string table. And so what this allows us to do is have 2 different entries in the entity table that point to the same string. So what we're able to do is store a single copy of a string. So yeah, if we want to talk, we were talking about how much space we saved with all that fancy stuff earlier. Not duplicating strings is arguably the biggest space saving, because strings take up quite a lot of space on their own, but then also the tags to change color to like red and then change it back to white, that's another 12 bytes. So yeah, deduplicating strings is very nice. And the reason we're able to do this when we weren't able to previously, for example, is, well, just how it works. But if we were to look at the string for like let's say we had 2 hints on a hint sign, like hint A and hint B, right? And then we have a different hint sign where it's like maybe it's hint C and then hint B again. Well, the hint C plus hint B string was actually treated as one string, and the hint A plus hint B string was actually treated as one string. So even though the B section was in both of them, since it wasn't split up based on node, we weren't able to reuse that string. But now since we have each individual hint treated as its own node, then that hint B, we are actually able to only store one copy of that string, which is pretty cool. And that saves quite a bit of space. Okay, so this slide, we're just talking about branch and event patches, which we've kind of gone over already in that example. But yeah, the entities are 8 bytes, with the first one being a magic byte, and then the other 7 are either that byte, which means they're ignored, or they're an actual value to replace. Yeah, as we have highlighted here. So magic byte FE, so anyone that's FE we don't mess with, and then the 0037 we do actually change. And since there are only at most 7 bytes here, right? And we have 256 possible values for the magic byte. 256 is greater than 7. So even if, FE, let's say instead of 0037, we wanted this to be 00FE, then instead of using FE as the magic byte, we could use like FD, for example, and then just have FD, 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 00FE, FD, FD. So that we're guaranteed to always be able to create a magic byte. And then basically picking a magic byte that doesn't conflict is handled by the generator code. Okay, so we have event node and branch node patching, but we don't have message node patching. And why is this? Well, it's because message nodes there's a lot more going on with them, and they're used in way more locations. So branches and event nodes are kind of very contained. There's like one branch proc function and one event proc function or something. So we kind of only have to hook into that function in 2 spots. The first is to patch the branch node before we pass it to be operated on. And then the second is for handling the query result of that branch in order to handle mapping it to where we want. And the same for event nodes. However, message nodes are used, they get loaded in way more locations, so we would have to patch a ton of places. But also there's kind of just not a need to do more than what we're currently doing. So if some need arises in the future, then we can kind of mess with it as necessary. But for now, there is not a need. So we didn't add code for something that we don't actually need it to be there. Okay, finally I want to talk about static inf changes. So the only inf change we need is for custom hint signs. We want to make sure that they're using like a normal text box style. And so if you recall previously, like in the previous code, we used, recall as in you were already familiar with the code. So I'm talking about like 1 person. Anyway, the inf index we used was 1369. And so we still end up using that in order to get that basic style, though we also use 136a for when there's a options node. But rather than like adding a new entity type and then using a bunch of extra data, since we are only messing with the inf indexes for custom hint signs, and we know that custom hint signs, any flow ID greater than or equal to 7,000 hex is reserved for custom signs, then we can just handle that in the code without having to put it in the GCI data, because it would use a lot of space for no reason really. So just to reduce complexity and code size, we handle it in this one way, rather than through an entity type and all this other stuff just to get the exact same behavior. So but yeah, like with the last slide, if there's a need for more inf type stuff, then we can handle it then. Okay, and this was the last slide for the talking about the implementation of the types of changes we can make. Hopefully it went okay. I feel like I didn't do a very good job explaining because, I don't know, it's like, it feels kind of hard to explain without going through all the code, but then a lot of it is kind of just optimization where, I don't know, just hearing it talked about might not, I don't know, maybe there's only so much I can do without you actually looking at the code. So anyway, I feel like that section was kind of weak, and I apologize for that, but yeah, we're gonna move on to the next section. That's the end of the talking about the implementation, I believe. The rest of it is going to be talking about stuff within the game and how it works, I think. Let's see. Now the next section is how talking to Midna works. Yeah, we might have a little bit in here related to the patching that we did on this, but it should mainly be like vanilla game stuff from this point forward. So, okay, so let's get into how talking to Midna works. So in the Midna actor execute function, whenever you press Z, then you have the message flow initialized with flow ID BB9, which is hard-coded. So let's take a look at that. So we're in EA Midna C execute. Not going to claim to understand all this stuff. Obviously, there's a bunch of stuff going on here, but the thing we want to focus on is right here. So you can see BB9 as the flow ID is hard-coded into the execute function here. So, and while we're looking here, this get event ID 45 and whatnot, this is related to transforming or warping, that kind of stuff. So, but anyway, the main thing right now we're focused on is initializing the message flow with BB9. So if you recall, this is in Zel00. BB9 goes to node 1B, and that one is right here. So, as we said earlier, not talking to Midna, but you know, pressing Z to pull Midna up. This is where all the magic starts. Okay, so we've talked about this a little, but yeah, the very first check is if you're underwater or swimming. Let me see. Yeah, so let's just talk about this for a little. So yeah, the very first check is if you're underwater or swimming. You probably know if you press Z to pull out Midna while you're like in water, then it will go directly to talk to Midna, since there's no transform or warp menu. And so that's this where the return value is 1, and it calls an event node with event index 9 and 0 for the event params. And so event index 9, which is actually just event 9. So if we go to the event 9, so get params, yeah, I don't think it actually does anything, but the important part is right here. So we're in the event node proc, and then after we do the proc, which in this case I don't think actually does anything, but we switch on field 1, which is the event index. And so if it is event 9 right here, then we do some stuff here. So if the parameter is 0, you can see inside here we're doing some Midna specific code. If the parameter is not 0, and we break at the end here. However, if the parameter is not 0, then mflow, we set that to the parameter, and what mflow is the flow ID or the FLI value. So that's how event index 9 can be used to change to a different flow ID. But the case we're interested in right now is when the parameters actually are 0. So if you are press Z to pull up Midna, and then you're in water, so it goes here. So this is event index 9 with parameters set to 0. So what happens here? So this line where we're checking get a link actor class get Midna message num. So this is checking if there is an override. And so the override, if you recall from the demo way earlier, when we were at the owl statue at the southern end of the Bridge of Eldon, how eventually Midna started saying, hey, you don't need to be here right now. And then even after the first time, when we pressed Z again, it pulled up that hint text about there's nothing you can do here right now. So that is an example of the Midna override. And so that would be down here. So when the value is not FFFF, then we actually want to use that message num right here. However, if there is no override, then we get the message number based on, I assume, the room. Everything here seems to suggest room and not stage, but yeah, I'm not 100% sure on that. I mean, room control, status room control. I'll say room. But yeah, otherwise we use a default value. So let's look back at the slides, make sure I'm not skipping over anything. So it's for there. If it's non-zero, use for things other than talking to Midna. However, yeah, for example, when you try to buy bombs, there's a complex graph which can send you to several different subgraphs. So if we look here, is this a bomb one? Yeah, this is a bomb one. So the bomb graph, they're all pretty insane, but you'll notice that they also use event 9. So event 9 with a bunch of different event params, those being the flow IDs it's sending you to. So yeah, it's not strictly used for Midna. But let's get back to where we. However, when the event params are 0, it is used for Midna, which is what we have on this slide here. On this slide. Okay, so yeah, if there's an override, such as boss fight or Midna thinks you're taking too long, then it uses that. And then, yeah, we leave that override behavior alone, so it still works normally, as we saw in the demo earlier. Otherwise, it reads the flow ID using this, as we saw in the code. The most common and the default value appears to be BB8, which if we look here, BB8 goes to 8F. So let's look up node 8F. Okay, so this is pretty crazy. But we start here, so it's kind of like this. So did we clear Palace of Twilight? If we have cleared Palace of Twilight, then we're going to 177D flow index. If we haven't cleared Palace of Twilight, then did we clear City in the Sky? If we did clear City in the Sky, then we go to 177C. Okay. If we didn't clear City in the Sky, did we clear Temple of Time? So you can see this is where the sort of Midna gives general stuff about what you're supposed to be doing based on how far you've made it in the game. So that is where that happens. And as you can see, each one we're going to different subgraphs, which can have their own logic. So let's look at this one. So this is, you've completed Palace of Twilight, so you're pretty far in the game. So this is 177D, which is right here. So we're going to node 10A. So let's see what that looks like. Okay, well, that's very small. Yep, and that's all there is to that one. Is it 8F? yeah, let's try a different one. So if you've done City in the Sky, but not House of Twilight, then 177C, 177C, so that goes to 106. Okay, so this one's slightly different. And I think they can get more complex than this, but we're not going to go through all of these. Okay. So this is if it's if it's played the mirror complete cutscene, I guess. So if it says, if you haven't watched that yet, then Midna says, you've collected all the shards, go to the mirror chamber. But if you have seen that cutscene because you've completed the mirror, then she says, dance in the Twilight Realm, and go there, basically. So that's an example of how talking to Midna can resolve to like, here's what I'm supposed to be doing in the story. But interestingly enough, that BB8 is kind of just the default. There's no special thing based on where I am. The interesting one is like outside Palace of Twilight, it's BB8, but as soon as you enter this whole get status room, DT, room control, stay number, file list message, that instead of BB8, which is what most rooms use, it's 3F0. And then notice that 3F0 is less than 3000 BB8, which, as you'll notice, BB8 is exactly where Zel00 starts. So instead of that, it's going to be 3F0. And we know that dungeons are in Zel5. Okay, 3F0 is all the way down here. So 144, and this is in Zel5. 144. Okay, so that starts here. And so yeah, this is kind of interesting because it shows what the Midna, talking to Midna, resolves to while you're inside Palace of Twilight, I assume. And so if you've actually cleared Palace of Twilight and you're inside Palace of Twilight, then she says, we can't stay in the Twilight Realm. Let's go to Hyrule, right? And then there's a bunch of these checks. Use that sword to cut through the darkness, blah, blah, blah. So you can see how, like, as we move down this, we're kind of getting, this is like earlier in the dungeon down here. And then as we move, like here's stuff about the souls. We're moving closer to over here once we're completing stuff. What is this one? Event E, this would be 1 and 3-7 is U16 params most likely. I'm not familiar with E. And we don't need to look into that more right now, but okay. So anyway, but the cool thing about this is that this text where you're talking to Midna, which is like super Palace of Twilight focused, is actually stored within Zel05, which is the dungeon file. So how I've talked about how there's like subgraphs or whatever. Interestingly, the subgraphs don't even have to belong to the same BMG file. So we were in BMG 0, but then when we changed to a new flow ID, that flow ID actually belonged to the local BMG file, which happened to be Zel05. So we actually jumped from Zel0 to Zel05, all while still within the same message flow, which is kind of cool. But okay. Yes, so otherwise it reads it, and then there's that Palace of Twilight example. So what we did, there's a minor patch we applied here, if we look in this code. So what we did was essentially patch this to where instead of actually looking at, like, using the value that is looked up, which usually is BB8, but can vary based on the room you're in, since we're never actually showing whatever the default text would resolve to, because we have flags set, for example, related to like the mirror chamber, to where that stuff just straight up doesn't work in the first place. So that text never shows. So what I did here was like a simple one-line instruction patch, I believe, to where we just always use BB8. And the reason we always use BB8 is because since we can expect it to either be the override, in which case we don't do anything, or it's going to be BB8, then all we have to do is intercept BB8 directly. And then when it's going here, then we say, okay, you're not actually going there. You're going to our custom flow, which will be for the menu where we say change time of day or hints. Or if they can't change time of day, then we just go to hints. So it actually starts on a branch node, but we'll talk about that in a second. Okay, very first branch node, checking if you're swimming underwater. If you're in water, sends you to the talk to Midna resolution. Okay, so all of that stuff I was talking about, let's refresh. Okay, so all of that stuff I was talking about, all the resolution and blah, 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 that is when we have event index 9 with event params 0. It goes through that resolution process. But let's say, okay, we're not underwater. And then let's say we don't have the shadow crystal and we haven't completed MDH. Then pressing Z to talk to, or like bring Midna up is going to go all the way down here. So this is like really early game stuff. So interestingly enough, if you haven't actually completed MDH, but you have had MDH start, then you can see it goes to event index 9 with param 0. So it's just talk to Midna. However, if we're before MDH starting, then we like keep going down this way. First portal warp. What is this? That's another talk to Midna. But in some cases, you'll actually make it down here. That's checking, are you allowed to warp? And we'll talk about menus, but this basically sets up that we're going to do a menu, and then body box at the bottom, the options, and then handling the result of the selection. So this is very early on, like in a Twilight, you're actually allowed to warp if you're in like a Twilight state. And so warping would be selection 0. Talking to Midna would be selection 1. And so you can see this is just the normal talk to Midna. Or if we go this way, so this will be selecting warp. And then there's a check here, cannot warp to Linearu. I believe this is, yeah, this is when you start Linearu Twilight. I think I checked this, I can't recall exactly, but I think it's as soon as you start Linearu Twilight, because if you recall, the bridge of Eldin gets warped away as soon as you destroy the rocks. So warping, if you were to like warp back to, I don't know, somewhere in Eldin immediately, then you'd have no way to get back to Linearu Twilight in order to continue the game. So I think that's what this is for. Don't quote me on that. But anyway, assuming there's no block there, then we go to event index 8 with, this is 2 U16s, so this would be event ID B or something, which funnily enough, if we look at the Midna code, B is 11. Oh, here it is, B. Event ID B. This is like kind of random. Not really what we're looking at here, but I kind of figured this out recently, which I thought was interesting. So this message flow, get event ID, get event ID. So it, let's see, returns M event ID, and then also inserts this field 30, which if we go to event 008, there's this random fundraising thing. If, you know, I don't know what's going on. Cool. But anyway, ignoring that because we're not doing fundraising, this actually flow node params. Interesting. But what I wanted to look at was here. Or wait, where is it? Oh, okay, yeah, here it is. Sorry. So yeah, in the event node proc, after, if it's case like query 8, then we actually call get param passing event ID and field 30. And these, the the parameters from this actually get written on those. So im event ID, we write B, and then the second U16, which is all 0, gets put into field 30, which I'm not sure what that is. But back here, so we call get event ID. This is item ID, I guess. Okay, sure. I guess that's right. Anyway, well, maybe it is. I have no reason to believe it's not right. Anyway, we're talking about the event ID. So you can see the item ID. Okay, I don't know why I was questioning that. Yeah, so we'll say that's item ID, which is interesting because why is it called field 30 if you know it's item ID? I'm not sure. Okay, I should just stop talking. But okay, we return the event ID here. There's a 4 or 5, blah, blah, blah. But anyway, event ID B, you can see it's the portal warp stuff. Which is to say, anyway, that's kind of random tangent on event 008. So anyway, back over here. So let's say you actually, this is post MDH, right? Down here. Because Midna revived and the barrier appears. So that's post MDH down here. If it was, you actually got the shadow crystal at the end of, like once Midna gets revived, then the first thing you do is you go get shadow crystal. So this portion down here is after Midna gets revived, but before you get the shadow crystal. So, yeah, there's some checks here. But there's a different menu. So you're like allowed to warp, but you can't actually transform until you get the shadow crystal. However, once you get the shadow crystal, then we go to BCF, which I think we've shown already. So Zel00, and then we go to BCF, which is right here, and it goes to 1AF. So if we go to 1AF, then this is this giant graph we've seen before. And while we're here, there's all these Arbiter's Grounds clears. So this would be, you haven't spun the pillars, but you did clear Arbiter's Grounds. So that would send you here to BD0, which is 1C3, which puts you here. So there's this whole Mirror of Twilight is so close, let's hurry. I don't recall, but I think that's like relevant for speedruns due to flags and whatnot. So anyway, there's this whole graph, which is like purely, I've cleared AG, but I didn't spin the thing yet. Yeah, it has this whole entire graph, which is kind of interesting. And then it sends to that subgraph. It can send you to other places most commonly. Yeah, this one, this is the like later in the game. I have Shadow Crystal. It's going to be one of these menus. One of them, this is the transform into human side because you're wolf. This is the transform into wolf side because you're human. So most commonly, this is what will happen. Or if you're on a horse, then like a horse or boar, then it just goes directly to talk to Midna. But okay. If you don't have, yeah, okay. Okay, so let's talk about our talk to Midna patch. So as we already described, the flow ID in the resolution, we always just set it to use BB8. And then we intercept here to go to our fake nodes instead of the normal story objective thing. So it goes to our custom flow instead. Okay, so when we go there, what does this actually look like? So it sends us to a custom branch node first with our custom can change time of day function, which is based off query 44, which is the one that's used to determine whether to show the menu that includes warp or not. So see, this one doesn't have warp, this one has warp, and it's right here, query 44, which does this. And that's basically checking if you're allowed to warp or not. Which I think, oops, wrong thing. Yeah, check accept dungeon warp a link. So, return check except warp. Sorry. Okay, here we go. Yeah, so here's kind of where the bulk of that function is defined. It does really old, or what am I saying really old? I was reading old century. Yeah, there's a ton of checks here. A lot of them are related to what room you're in. For example, are you in Forest Old Century? I think that's like the Temple of Time past area. And then there's like, are you in Castletown or RSP161, which I think I wrote in here. Okay, yeah, I wrote that somewhere else. But what that is the star tent. So if you're in Castletown or a field and you're not in the star tent, and yeah, so that's kind of what's going on there. But yeah, our function's based off of that implementation. But we also check to make sure you're not in Twilight because, you know, you can't change time of day if you're in the middle of clearing out Elden Twilight, for example. And then, yeah, there's several checks here, like related to slide polygons and ground hit and whatever, stuff that's not really relevant. So we kind of only use the parts that are relevant, and then we added the Twilight check. Okay, so if we can change time of day, then we go to the custom menu. If we can't change time of day, then we continue as if they selected hints in the menu, which is comparable to how, like in the vanilla game, if you press Z and we can't show transform warp, then it just goes directly to talking to Midna. It's the same way that works. Well, the menu can't show, so it just goes directly to the hints text. And the way the hints portion works is basically the same as the custom hint sign example we went over earlier, where it's on that one node and it kind of just loops on itself until it's done, so that we can, you know, you are able to basically put as many hints as you want there. But okay. So let's look at if the menu actually does show. Then if you select change time of day, then it goes to our custom event node, which has the change time of day event, which is a custom event, which triggers that code. Yeah. And if you pick hints, then it, you know, goes to the same thing, or pressing B just backs up. Next, let's talk about tags and menus. So message flows are fairly straightforward, but worth specifically learning a few things. So in addition to the general stuff we've gone over, yeah, we're going to go over a few more things. And then once you understand the tags and menus, which we're about to talk to, you probably should be able to understand the vast majority of stuff that you'll see in the BMG graphs when you're viewing them on this site. Which I'll work on trying to get public. I don't know what order I'm going to be working on this stuff. I definitely want to try to get the PRs up, but this will be coming in the future. And yeah, we'll be going fairly low level on some of this stuff, but yeah, this isn't like a complete deep dive into how everything, like absolutely everything works, which would be cool to do at some point, but you know, I got to work on rando stuff, you know. All right. Okay, so to talk about tags, so a tag is something like this. So if let's go back to the graph site. So I'm sure while I've been going over this, you've seen these all over the place where it's like 1A, blah, blah, blah. There's a bunch of them and they are all slightly different. So let's break down what exactly is going on with these. Okay, so uses for tags. They can be used for text substitutions, for example, the player name, how many bugs you've turned in, and so on. Some of them are also commands that execute code. For example, they change state. So now we're setting the color to red, or okay, we're setting the color back to white, or we're changing the font size, stuff like that. And in fact, color, just to go over how color works if you don't already know, we have a tag similar to this, well, actually exactly like this, which updates the color to orange. And then we have some text. And then we have a tag that changes the color to white. It doesn't like reset it to white, it changes it to white. And then if we have more white text, and then we can have a tag, okay, now the color's red, and then we keep going, and the text after that's red. So if you've worked with HTML, which is what I've done a lot, I was kind of thinking color would work like where you like have an open span tag, and then you have your contents, and then when the tag closes, that's kind of the end of that section that's colored. But that's not actually how it works. All the change, like every change to the color is manually declared. So it's like, okay, color is orange, write stuff. Color is white, write stuff. Color is red, write stuff. But anyway, so that's kind of how color works. So some other stuff that tags can do, they can cause a delay before showing more text. So I believe, for example, when you get certain items, it'll be like, you got this item, and then there's a pause, and then it'll be like, and blah, 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 here's how you use the item. Also for managing menus and options, manage menu and options, okay, and a bunch of other stuff, like quite a lot of other stuff. So here's a basic tag example. This is the one we were looking at on the previous slide. So every single tag, it always starts with 1A. That indicates the start of a tag. That's like in ASCII, it's not a rendered character. So anyway, they use 1A to start the tag. The next byte, which is 6 in this case, is the byte length of the tag. So 1, 2, 3, 4, 5, 6 bytes long. So that's why this is a 6. And then the next 3 bytes are what kind of tag it is. So the FF and the 0000. So these 3 bytes are the kind of tag. And in fact, they're kind of grouped by the first byte, and then within that first byte category, then you have the next 2 bytes are sort of the exact implementation within that category. So, so the first byte, FF, is the tag group, and then the last 2 bytes is the tag code. According to the decomp, that's what they're known as. Okay, and then anything after that is params, which are handled based on the tag type. So in this case, 1A starts a tag, 6 is the byte length, and then FF0000 is the sort of like what kind of tag it is. And then anything after that is params. So the 08 here is a parameter which is handled by this FF0000 tag type. And 8 translates into orange for the color. So FF0000, that's for setting the new text color. And then 8 is like this byte is for handling exactly which color. So like if it was 0, that would be for white, for example. Here's a different example. So when you're talking to Agatha, she has different lines about, you've turned in this many bugs, or we only need this many more bugs, and then we'll have all of them. And so we have 1A, 06 is the byte length. So 503, this is the tag type. And then 0 is the parameter. And the bottom one, we have 1 as the parameter. Yeah, group 5, code 3. So if the parameter is 0, then we resolve to the number of bugs you've turned in. However, if the parameter is 1, then we resolve to 24 minus the number of bugs you've turned in which case would be how many bugs you still need to turn in. And so it's able to use kind of the same code, but it uses that parameter to pick which number to resolve to. Okay, so next we'll look at a Furigana example, this is like JP only, and I think these tags only work in JP, but it's just, I want to go over a few examples here to show how the parameter can actually vary in size even for a single tag type. Okay, so what is Furigana? So it's these small white characters above the more complex characters. It's essentially a pronunciation aid, usually for like younger kids and that kind of thing. It can be used in other ways that we don't need to get into really. But yeah, in these cases, pretty much everywhere that we see it here, it's going to be used as a well, yeah, literally everywhere we see it here, it's going to be used to help pronounce the kanji underneath. Okay, but it can cover a variable number of characters, and it can itself be a variable number of characters. So if you look at this one, see how it's 1, 2, 3, 4 characters worth of text, and it's covering 1, 2 characters down here. Whereas this one is 1, 2 characters long, and it's only covering 1 character down here. And this one is 1 character long, and it's covering 1 character down here. So let's talk about how those can work. So here's a tag from the ball and chain item description. So it's 1, 2 bytes long, which should be 16 plus 2 is 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, so that checks out. Okay, so 1A starts the tag. 1, 2, or 18 decimal is the byte length, not the character length. That's the byte length. FF0002, so those 3 bytes is the tag type, which is hiragana, which I believe only works on the JP version of the game. Okay, so after the first 5 bytes, you're always going to have parameters. And so the very first parameter, 03, is how many characters the hiragana should be centered over. And then the remaining 6 characters are shift JIS or shift JIS. I'm not sure how you say it. It's like a Japanese encoding that's not UTF-8 or UTF whatever. And that, anyway, that's how the Japanese is encoded in the game. And so for these characters here, they're each going to be 2 bytes long. And so we can see 3 was how many characters we're covering, and then we have 82CD, 82A9, 82A2, 82E8, 82E5, 82AD. So you can kind of see how those all start with 82. But yeah, so it's these 2 bytes is 1 character, character 2, character 3, character 4, character 5, character 6. And if we look here, this is 1, 2, 3, 4, 5, 6. So that the text here is shift JIS encoding for these 6 characters. And then the 3 characters that this would appear over in this case are these 3 kanji. So this is how you pronounce these 3 kanji. And so the hiragana tag shows up immediately before the actual characters. So it would kind of look like this. You have the tag, which is these bytes, for the pronunciation, followed by the 3 kanji for the how it's actually written. A couple more examples. So yeah, if we recall on that previous one, it was 1, 2 bytes in length. However, this one is E bytes in length, and this one is A bytes in length. And so if we look here, FF0002, so 2 means we're covering 2 characters, which would be these 2 kanji. And then 8, or sorry, not 8. Yeah, 8, A2, wait, 8, A2, E, E8 to A2. Okay, I think I wrote that in wrong. I think that's 8 to A2. 1 second. 2, yeah, 8 to A2 for this E character. And then the third character is E. Okay, yeah, I think I just wrote that wrong. 8 to A2, 8 to C1, 8 to BD, 8 to F1. So that's 1, 2, 3, 4. So this is technically 4 characters. 1, 2, 3, 4. Covering the 2. And then if we look at this one, A length, FF0002's hiragana. 1 is how many like underneath characters we're covering. And then 8 to EO, 8 to C7 for these 2 characters. And so this only covers this first character, and then there's more stuff after that. And yeah, the hiragana is from notes I wrote several months ago when I was looking at item descriptions while working on the hint message stuff. Okay, I say months ago, but that might have been over a year ago actually. But anyway, okay, so you can also have plain ASCII in the hiragana. You would never see this normally, but things still center correctly. Or if the character's under the hiragana is like regular ASCII, it's like the measurements are handled properly to center stuff, which I thought was interesting. But yeah, to mention there, the length of the tag, 1, 2, 3, 4, 5, 6, yeah, it could actually be an odd number of characters in that case, or an odd number of bytes, which is not super important, but anyway. Okay, now let's talk about menus. So when I say menu, I'm talking about things like these. So you have the text at the bottom of the screen, and then you have some text, or the options over on the right side. And it can be 3 different options, or it can also be 2 different options. That's all it can be, 3 or 2. There's no like 1 option menu or anything. Okay, let me pull this up. So we've already seen this plenty of times, which you should probably be familiar with. But yeah, we have the what is it, and then there's like a 3 option version, and then there's a 2 option version, depending on if you can warp or not. And then there's ones down here as well. And yeah, we'll go over the way this works in great detail. But essentially, there are 4 nodes involved with showing a menu. So the first one is the event node, like this. So we have the event node, and then we have the body text node, and then we have the options node, and then finally we have a branch which handles the result of the selection from the user. Okay, so event node, which is generally going to be event node D, right? So this one's event index D, which is event 13. And then this one is event D as well. These ones are also event D. So event D is used for any menu that looks like these ones. There's a different kind of menu which we'll go over as well. In fact, I think it's the only other kind of menu. So the options aren't on the right. It's when you're selecting like a bomb bag, for example. Like if you buy bombs and they're like, which bag do you want the bombs to be put in? Or if you're selling bombs and it's like, which bomb bag are you selling the bombs out of? And then you're kind of moving left and right down within the text box. We'll talk about that later, but that's event 1D instead of just event D. But okay. For now, we'll be going over event D. So you have the first message node, which is the text that shows at the bottom of the screen. If the text doesn't fit into a single box, then we delay showing the menu on the right side until we make it to the last page of the text. So for example, if the text was, let's look at these images. Okay, so each of these ones are actually 2 lines of text, as you might recall from earlier. In English, or not English, sorry, US and EU versions, you can have 4 lines of text per text box, and for JP, it's 3 lines. So I don't think this ever happens in the vanilla game, but if you did have like 6 lines of text, for example, then you would have 4 lines of text, and then if you press A to go to the next text box, it would show 2 lines of text, and then it would show the options, and so on. Which is more just, I tested that out because I was curious how it worked. You won't actually see that anywhere. But okay, then the second message node is the options text, which is either 2 or 3 options. Worth noting, and I'll go over this later, but if you notice, this is 00009 for 3 options, and it's 00008 for 2 options, which is actually critical that you handle that correctly. But we'll talk about that later. So anyway, very important distinction. Okay, and then the branch, which takes the result of the selection by the user and sends us to the correct node. Let's look at this example. So Zel04 9AE. 9AE. So Zel04 is for Castletown. Okay, so here's what I wanted to show out of this. This is the red potion selling Goron from Castletown. So I think the young kid. And you'll see here, we actually have event D here and event D here, and they both lead into, so it's like event node to set it up, then the text body and the options and the branch, and then this one's the same thing, event to set it up, the text body, options, and the branch. But they actually kind of converge starting at the options, which is pretty interesting. Because they send to the same place. And so I guess there's no reason to duplicate that. And let's see. spoke with the child Goron. Yeah, so if you've already talked to him, the very first time, if you haven't talked to him, then it's this text. If you have talked to him, then it's this text, I believe. But anyway, I thought that was interesting how they can actually meet up partway through. So, okay, let's talk about the event node, which initializes the menu. So, for example, right here. So, event will be D. It sets fields on the message flow instance, which will cause the next message node, which gets processed immediately after the event node, to call set select message as opposed to set normal message. So set select message is called to handle that text box at the bottom, options on the right kind of thing. Set normal message is for the normal messages where it's just like text box, press A, text box, press A, and so on. Also statically calls the message object C set select cancel position, passing its int param, and that controls what happens when you press B. More on the next slide. So let's quickly look at, okay, in here, this would be event 013. Okay, so this one, you have field 46 M select message and field 025, and then we also get the parameter, and we call set select cancel position using that parameter. So I do want to mark this. We also have event 029, which is this is the one for the bombs, or the bomb selection menu. So if I go between these two, you'll see that they are basically exactly the same. That select cancel position get param, that's like the same, it's just written differently. One line versus two lines. But other than that, the only difference is that field 046 is set to 1 on this one. And then field 046 is set to 2 for the bomb one. But let's look at set select message. So this is called in the message node proc. I haven't shown this until this point, which may have been a mistake, but I do kind of want to go over this now. So when we're procking a node in the message flow, while we should still keep going based on the proc status. So if it's not 0 and field 26 is not 0, then we keep going. And if you recall from way earlier, we talked about how the type of node, 1 was for message, 2 was for branch, and 3 was for event node. You can kind of see how that works here. And so if we go to branch node proc, for example, then the code here is very simple. We get the node, then we get the query function off of the node, and then we run the query function, and then we set the node index. Field 14, I believe that's what I'm calling the next node table. And so we get the proc status, that's like the branch result. And then using the base index of the next node table base index plus the proc status, the 16 bits, and then get that off of the next node table in order to set our next node index. So that's pretty simple. And then we have event node proc, which we went over. So you get the event node, and then you get its index from the event list to get that function, and then you call it. And then after that procs, then based on the what event index it is, you have different codes. So that's for like 8, 9, and then you have these ones, 21, 32, 33. Or by default, then you just set the next node index to the message. Well, this would be the next node table index. Field 014, that's the next node table. Also field 0, like field 10, so the second, like 16 bytes from the start. That's the current flow node that you're on, because I don't think that one's defined in here either. It might be, since I'm a little out of date here, but anyway, so that's those ones. And then if we look at message node proc, right here, so there's some different stuff going on here. Yeah, so field 0x10, that's the current float node index. But anyway, so if we have field 25 not equal to 0, then we have these set select message and set normal message stuff. Down here, not as concerned with this one. Here's the main thing I want to look at. So we can compare how this looks with these ones. So field 4.6 and field 2.5. So if 2.5 is not equal to 0, so if we look at where field 2.5 is used, let's see. Field 2.5, set node index, case 1. So we set field 2.5 to 1. Okay, so I think that's just general message node stuff. Field 4.6, I think that's the one that's more related to menus. Let's see. Yeah, so field 4.6, that's the one that we're mainly concerned with. So it's saying that we're going to be using, we have a menu coming up, and then if the field 4.6 is equal to 1, which is what happens with event D, versus set to 2, which is what happens with event 1D. This one is for bomb bag selection menus, whereas this one's for like every sort of menu with the 2 or 3 options on the right side. So anyway, select message is for the text box at the bottom with the options on the side. If field 4.6 was non-zero, but it was set to 2, then we still call set normal message for the bomb one at the bottom. And in fact, the bomb ones, it has an event node 1D, and then it has a single message node, and then it has the branch. So as opposed to a select message, which is event node, body text, options text, and then branch, this one's only 3 nodes. And in fact, you can see here, we read the params, which that's offset 4, I believe. Offset 4. Yeah, next flow index 1AA. So what we're doing here to set select message, we're getting field 0x10. That is the current flow node index. And then we're reading the options flow node index, right? Yeah, the options flow node index. And so we're passing pointers to those 2 message nodes. And then once we return from calling set select message, we actually set field 0x10, which is our current flow node. We actually set that to point to the options node. So our current node is this, and then our current node is this. And then after we call set select message, we set our current node to now be the options node, which means in the future, when we move to the next node, once they make their selection, the next node is going to be the branch at that point. So this line here is what changes us to being currently on this node to now we're currently on this node. So yeah, set select message, there's a bunch of special stuff going on in here, which we'll get into. Okay, so now we'll talk about the event D parameter. So the param indicates which option to treat as the user's selection when they back out of the selection with the B button. So if it's an int that uses the full 4, or no, it is an int, sorry, that uses the full 4 param bytes, though it is stored on the dmessage object C as a U8, and invalid values will lead to crashes. Yeah, which I tested. Okay, so there's actually, yeah, not very many valid values, and they are definitely within a U8. So for a 2-option menu versus 3-option menu, 0, if the parameter is 0, then you actually cannot press B at all. So you have to make a selection. You're not allowed to press B. It just doesn't do anything. I think there's a few spots in the game that use this, but I don't remember any off the top of my head. And then 1 is for the first option, so like index 0, the top option. 2 is for the second option, so index 1, the second option in the menu. And then if it's a 3-option menu, then 3 is for the third option, and 4 is for a hidden option. Or if it's a 2-option menu, then 3 would be for a hidden option. And the hidden option in most cases is going to be pressing B to sort of back out without doing anything. So it's sort of the none of the above option. But okay, so the branch results subarray in the flow next node table only needs to include entries for valid options. Hidden option only needs to be handled if it's actually used. That might be slightly out of date. I mean, it's true, but the thing is hidden options are only used based on, if there's a hidden option being used, then the query function on the branch afterward is going to be something to indicate that. So if it's a 3-option menu with cancel position set to 3, meaning index 2 of 0 and 2, then the results only need to handle results 0 and 2. Charlotte does this, for example. So Charlotte is using a query function that never is used with a hidden result. Technically, you can use a hidden result, but the game never does that. So moving on. So the first message node, so inside message node proc, it calls set select message since the previous event node set a field indicating that a menu is coming up. So as we saw, that was set select message. So that was this field 46, which got set to 1 by event D, or 1D sets it to 2, but that uses a normal message. So set select message, set field 46, which indicated that a menu is coming up. Inside, or included in the set select message params, we have pointers to the 2 flow nodes, the text box and the options. As you can see, param 1 and param 2 here. Param 1 being the body box and param 2 being the options. Note that immediately after returning from set select message, we have update field 0x10 on the message flow, which is the current flow index we're currently on, to be the flow index for the options message node. So the next node will be the branch node, which we've already talked about. Okay. Inside set select message. So here we are right here. So we convert the flow node pointers we receive as parameters into their message ID values. And so we take the flow node, and then we get the inf index at offset 2 to get that inf entry. And then we read the message ID value at offset 4 of the inf entry to translate it into the message ID, or the mid value. So that's what happens here. It's written with tens, which looks weird, but if you step through what actually happens here, we're getting the message IDs. Okay. So then we call fup message manager message set, passing the 2 mid values or message IDs. So one for the text box and one for the options. Internally, this calls set message index on the statically available D message object, passing the 2 message IDs, and we also store those on the message object instance. Okay, so let's see what's going on there. So fup, so in message, this is like the ID of the message object instance, I believe. So if there isn't one, then we don't, well, anyway, we don't need to worry about that, but, so foff message and message set, let's go ahead and find that. That would be down here, here. Okay. Yeah, I think they're about the same, but down here, okay, receive the message IDs as parameters. Yeah, so this is where the code gets weird, right? So this is message index, but in my opinion, that's message ID. It's the mid value, okay? The reason this gets confusing is because here you have message ID, but this is like the ID of the message object. So maybe a better name for that would be message object ID. But we're searching by ID for the message object. So anyway, so I'm going to call this message object ID. It's the ID of the message object. Okay. So these mid values are stored on the D message object instance. This is inside set message index. So set message index, this thing we're passing in is actually the mid value, which is a message ID. Param 2 is also a message ID, but this is the message ID for the options. So this is for the body box, or the body text box at the bottom. Param2 is for the options. Okay, so now let's go to message object C, set message index. So yeah, this is what we're looking at. So quite a lot going on here. So param1, this is the message ID or the mid value for the body text. So we store that in field 158. And then is it param2 field 15C? Yeah, param2. This is the mid value, the message ID for the options, and we store that in field 15C. So let's just make sure we're going through this correctly. For the options mid value specifically, we find the pointer to its literal string data and store that pointer on the dMessage object's jMessageT reference. If the mid value for the options is not equal to exactly 1000, we will try to convert it to a message index or an inf index. Okay, so that's happening down here. So there's this Revo message index stuff I mentioned before, which we're going to kind of move past that. What we're looking at now is field 15C, which is the options message ID. So if it's set to exactly 1000, then there is no options. And in fact, if we go back to the message flow and go to set normal message, which is right here, you'll see in the set select message, we're calling fop message manager message set, passing those things. But for set normal message, we're actually hard coded passing 1000. And there's a bunch of other locations. So like you see here, we're passing 1000. Let's see. Those are demo, as in like cutscene. So this one we're passing 1000. This one we're passing 1000. So 1000 is a like a magic value, which means there is no select message, which is the options. So if the value is 1000, then there is no select message. However, if there is a message ID which isn't 1000, then we convert it into an inf index, using get message index. So since the options message index was not 1000, we try to convert it to a message index inf index by searching through the inf entries until we find one for which its mid value, which is at offset 4, matches, and we return that index. If it's not found, then we return a different magic value, 264, which is 612 decimal. I have no idea what's special about that value. But yeah, that's the magic value that they picked for whatever reason. So get message index, if it returns, in fact, set message index demo looks like they use it down here as well. But anyway, so if get message index returns 264 for the inf index, then we say, okay, there's also still no options. However, if it returns, if we find that message ID on an inf index, which isn't 264, then this code is basically getting the pointer or the address of the start of the string data within the date1 section or dat1 section, whatever. So this is the pointer to the actual string data for that options, and then it gets set as a select message pointer on the MP refer, which if we go to message object h MP refer, yeah, I just wanted to double check this. So that's the jMessageT reference, which is a property of the message object. Okay. So if the result is not that, then we use its offset in the data1 chunk, yeah, which is stored at offset 0 on the inf entry. To find a pointer to the string data, and we store this pointer on the dMessage object's jMessageT reference. Okay, so moving ahead, this is kind of the setup stuff. Oh, and in fact, way earlier when I was talking about mid, where I said you pass in the parameter, and if that parameter is set to true during like the continue proc and whatnot, this param3 is the Boolean parameter I was talking about there. So if you want to go back way further in the video, where this is what I was talking about when I said the true parameter. But anyway, we're not going to talk about that right now or ever. But okay, So we set up this stuff on the message object. And we're just going to hand wave and say magically at some point in the future, the message processing is going on, and the string data is actually going to be processed at that point. So here's an example of a text box message. So what do you think? Are you interested? And then we have this tag at the end. So later on, at some magic point in time, is what we'll say. The string for the text box will be processed. So this stuff's getting processed character by character, and then when it gets to a tag, it sees character 1A, and it basically jumps forward. It sets its current position to pick back up at based on the byte value here. So we jump forward 5, and that's where we're going to pick back up. But first, we're going to process this entire tag. So when this tag is being processed, it pushes the pointer to the option string, which we talked about storing on the JMessage reference. So that gets pushed onto like a stack where I assume it gets processed shortly after that. And so that's what this 1A05000020 tag that you see at the end of all the option or the body text boxes, that basically instructs it to it sets it up to process the options string. And yeah, this tag is always placed at the very end of the text box string in the first message node. Okay, so we said that we push onto the stack the pointer to this to the string, which is the options message string. So then this literal string data will start getting processed as well once it decides to process that off the stack. Okay, so here's some examples. So transform or talk, and then this one's transform warp or talk. As I mentioned earlier, if it's 2-option menu, then you have to use 8. And if it's a 3-option menu, you have to use 9. And so as the string data is being processed for the options node text, this tag will be processed. So as its tag, note that each option other than the final one in the menu has a new line after its text, which is not strictly necessary, but it seems like all menus might be written this way. Yeah, so see how I go from like transform into wolf, and then I go to the next line. There's a new line character here, which isn't strictly necessary, but that's like how all the vanilla menus are written, so I would probably just stick to it that way. Though I think it probably renders the same either way. But yeah, in the text for these different things, so it's like no player name, the darkness is new line, too powerful in fog like this, new line, remain in wolf form. So any new lines, like I only jump to a new line in the text here if it's actually written that way in the string. So after every one, except the very last one, after every option, there's always a new line character. So that's just the pattern that we should match if we want to match the vanilla game exactly. But okay. Okay, so let's talk about the options tag processing. So on the JMessage reference, if the select num, which is the number of options, has not been set yet, which means it's currently 0, then when this tag with the value of 0000008 is processed, it'll set the select num to be 2, meaning there's 2 options. Or if the tag is 0000009, then it sets the select num to be 3, which means it's a 3 options menu. And then if we look at the parameter at the end, so if the parameter is 1, like this, see how the parameter is 1, 2, 3, or parameter 1, 2. So if the parameter is 1, so for these two examples, then it updates the initially selected option to be at that position. So this never happens normally, but if you have multiple options with a 1 param, then the last one to get processed, which would be whichever one comes last in the message, will overwrite previous ones, and it will end up as the initially selected option. So if this was 1, 2, and then 1 again, then the menu, when it displays, it would actually default to talk to Midna. So that's kind of how that works. This never happens. You can pick any option in the menu as the initially selected one that way. Param values that are not set to 1 don't appear to actually do anything other than make it prettier to read. So this is like 1, 2, 3. This could be like 1, 7, 8, or like 1, 5, 3. The ones that are not 1 appear to not actually do anything. The position index is what determines the branch result index, not the parameter. So it's not like if we did 1, 3, 2, that picking, talk to Midna when this was a 2 would change anything. The top one is index 0, the second one is index 1, and the third one is index 2, or in this case, top one is index 0, second one is index 1. So the parameter is not important. Later initial position example. So this is when you're doing the Master Sword puzzle and those two giants who talk to you. So this is when you talk to them. So the event sets up the menu. Then you have the body text at the bottom, and then you have the options text on the right, and then the branch that handles your selection. So in this case, it actually uses 2, 3, 1. And since the 1 is here, that means continue is the one that it defaults to having selected. However, this is still index 0, index 1, index 2 as far as the selections go. Later initial position example. So this is Death Mountain Wrestling. So you'll see it actually uses parameter 0, parameter 1. So as we've said, parameter 1 is where it'll default. And then you also have these other ones where it's parameter 2 followed by parameter 1, which is maybe based on the previous slide. That might be more of what you expected. In fact, it's kind of interesting that this 0001 actually exists at all. I scanned through the different files. So these two nodes in this flow are the only spots that this happens. Only spots this is going on. Okay, only spots are the only spots this happens in the normal game. It's like a smaller font too, maybe. Okay, also seen in two nodes in Zel99, which is that test file, though it's not used. But yeah, if we used 0802 challenge here, then it would be equivalent. And that way of doing it is much more common at 20 instances compared to the 2 that show up in the vanilla game. And then there's no version that uses 00 for the 3 option menu. So, but yeah, that just goes to show that, the parameters aren't actually important other than the 1, basically. All right, now let's talk about the branch node that follows. So back here, so we have, event node, body, text, the options text, and then we have the branch. So in this example, query index 24, which is query 37, but this one's like query 36, there's different ones. So the branch will have one of the following 4 query indexes. So index 0 for query 5, index 4 for query 6, index 23 for query 36, or index 24 for query 37. These all search for the dMessage object C using the ID of the dMessage object C, which is stored on the dMessage flow instance. Then they read its select index property to determine what the user's choice was. Let's see if we can query 005. Look at that. Yeah, so this FOP message manager search by ID mMessage select index. So mMessage is the message object ID, which is stored on the message flow object. I believe it offset 20. Let's see if that's correct. Actually, that might be a pain to see if that's correct. dMessage flow. Yeah, mMessage at offset 20. But okay. So we find the message object, and then we get the select index, which would be what index was selected, like what option index. So would it be like index 0 for the top option, index 1 for the second option, index 2 for the third option. And then query 5 and 6, they set it on the m choice number. And if you look at query 5 and 6, you look at query 6, okay, it calls query 5, passing parameters that don't actually get used. And then it returns this m choice, it sets m choice number and returns that value, and then sets m choice number to that value and returns that value. So query 5 and 6 are actually functionally equivalent, which is pretty interesting, but we'll talk about that in a second. Okay, so query 5 sets mChoice number on the D message flow to this value and then returns it. Query 6 wraps query 5 but appears to be functionally identical, which we showed just a second ago. Then you also have query 36 and 37, which we saw right here. Okay, so those are the other two options. So query 36 is for two option menus that have a hidden option. It's also used for bomb-bag selection. And then query 37 is for three option menus that have a hidden option and also for bomb-bag selection, which would be the event 1D. Okay, so query 6, trying to figure out the difference between query 6 and query 5, because they're functionally identical. So places where query 6 is used, these are all the spots it's used. Charlo, Fanati, Koro, Master Sword Puzzle, Henna, Fire, Plum, Iza, and then 2 spots in Zel 99. So, but not necessarily every menu for these things uses query 6 over query 5. Okay, so then I looked inside Zel 99, which is that JP-only BMG file for testing, and then query 005 is used for every 2-option menu, and query 006 is used for every 3-option menu. And then these two, query 36 and 37, aren't used at all in this file. So query 005 for the 2-option menus in all these cases, and then query 006 for the 3-option menus for each of those two cases. And then, so that was led to the hypothesis. And in fact, if you check Zel 0 through Zel 8, every single file, query 006 is used for every single 3-option menu. And then I also went and confirmed that query 005 is used for every 2-option menu, as you might expect. All right, therefore, query 005 and query 006 appear to be functionally equivalent. However, query 005 is used for all 2-option menus, and query 006 is used for all 3-option menus. Do I say anything about this? I don't think I do. They're probably written that way in case they needed some special logic for 3-option versus 2-option. But anyway, the case is that they don't actually need to be different. But that's what the difference is. We just, I guess you could say, by convention, we use 5 for 2-option menus and 6 for 3-option menus. It's also possible they had like some debug code or something, like that didn't actually compile into the final product, but who knows. Okay, reading mChoice number from the message flow instance. Okay, mChoice number can be read off the dMessage flow instance after the flow ends, set by query 5 and query 6. So yeah, as we saw here, we're setting mChoice number, which is a property of the dMessage flow. So let's see where that's actually used. So let's look at DA object Seki Zoa. So this is the those Master Sword puzzle guys. So if you look back here, for example, if you recall, I said that any arrow that would point to FFFF, meaning the node, meaning the flow ends, I don't actually draw the arrow currently. So there are 3 options here, and in fact, I don't draw the arrow for any of them because they all actually end the flow. However, this sets the mChoice number, and so when we do the flow and then it ends, and I don't know exactly how this works frame by frame, but once the flow ends, we actually call getChoiceNumber, which I guess shows up here. GetChoice. Okay, maybe it's in the header. GetChoice. Yeah, it's in the header. Okay, so getChoiceNumber, which is an S16. I swear these, the number of bytes never makes sense on stuff. It's all kind of inconsistent, but in any case, the choice number should be it'll fit in 1 byte, I believe. But okay. If we go back to the Seki Zoa, then the choice number, these are like the indexes. So index 0, index 1, or index 2, or default, which is the same as index 2. And index 2 is continue, which means basically don't do anything. So this one, nothing happens. However, if it's 0, we set the event number property of the Seki Zoa to 3, and then we call event change, which is probably a whole process to handle that. Or if it was quit, then we set the event number to 8 and call event change to handle that. So that's an example of reading the choice number off of the message flow instance. So mFlow, I'm assuming that's a property of the Seki Zoa instance. or yeah, like a member. But anyway, no matter, yeah, calls that, okay. All right, next let's look at select push flag. So this is query 36 and query 37. Query 36 and 37. So query 36, we use that message object ID to find the message object instance, and then we look at the select index to, it's in this temp. Anyway, this is the selected option index. And then we call this static message object, get message object class, and then get select push flag, which is a very interesting name. But if the value is 2, then we set temp to 2 and return that value. Or in this case, query 37, if temp is, or if the select push flag is 2, we set temp to 3 and then return that value in either case. Okay, so what's going on with those? So these queries are used when there's a hidden option, which is when you press B to back out, for example. So you can press B to back out of the transform into wolf warp talk to Midna menu, and this selects the hidden fourth option. And then here's another example. Well, we've got 10 bombs for 30 rupees, 20 for 60, or 30 for 90, and it has the options 10 bombs, 20 bombs, 30 bombs, or you can press B to select the hidden option, which would be backing out without doing any of those things. Here's another example. Normal flight, Oasis flight, or special repairs. You can press B to do none of these. And another example, which bag should they go in? Talking about bomb bags, so it would be 1, 2, or 3. This specific example uses a different type of menu, which is a menu from event 1D, which we talked about, and we'll talk about it more. So those are some examples of where query 36 and 37 are. So dMessage object's mSelect push flag appears to only ever be set to 2 when backing out with the B button and some other checks passed related to the cancel position being the hidden value, or using the other menu type, which is used for selecting a bomb bag. Essentially, query code says, ignore whatever the select index happened to be. The result should be the hidden option index, one after the latest menu option. So for 2 options, hidden index would be 2 because 0 and 1 are the normal options, or for 3 options, 0, 1, and 2 are the normal indexes, and then the hidden would be index number 3. So that's what's going on here. So for this one, this is for 2 option menus. We say, oh, okay, it should show the hidden option, so result is 2. This one says it should show the hidden option, so result is 3. Okay, and for bomb bag selections only, not normal menus. So normal menus, box at the bottom, options on the right. The bomb bag selection is where you just have the bomb bag at the bottom. And I'll show an example of that later, I believe. Okay, it appears that if you back out with B, that the select push flag value will always be set to 2, meaning that query 36 and query 37 will always use the hidden index, regardless of what the event node which sets up the menu has as its param. The game is inconsistent here, where some of the event params would theoretically lead to the selection of the last bomb bag for both 2 and 3 bag versions in the list rather than the hidden option, but they still select the hidden option. Other bomb bag selections use an event param which points to the hidden value as expected. It seems the normal menus use the cancel position param on the event node as expected, but a bomb bag selection is specifically set to always use the hidden option when you back out with B. Probably because pressing B when on a normal menu and having a selected menu option is valid, but for picking a bomb bag, pressing B should never select a bomb bag. Note that all instances of pressing B to have a select a visible menu option use query 5 or 6 anyway, though. Can look into dMessage objects, see select proc for this. I believe status 8 is for 2 option menu, status 9 is for 3 option menu, and status 20, which is 1.4 hex, is for bomb bag selection. All right. Let's look. So we're in dMessage object select proc. So this is what's running every frame when there's a menu active, I believe. Quite a lot going on here. But let's try to find, yeah, so right here, this is like when the selection is being made. That whole select push flag, the select push flag is equal to 2. So get trig B, yeah, that looks like it's talking about trigonometry, but no, it's talking about pressing the B button. So if you're pressing the B button, select push flag is 2, otherwise it's 1. So basically backing out with B is when the select push flag gets set to 2. There's more logic up here about like field 1A3 and IVAR 8. Quite a lot of stuff going on, but essentially I believe this status local 8 is for a 2-option menu. And then status local 9 is for a 3-option menu. And then status local 20 is for the bomb bag. And so here is where we basically, it's just set to true. For the other ones, there's this other checks going on, like actually looking at the select cancel position. But for the bomb bag, we don't actually look at the select cancel position, which means the parameter on the bomb bag is kind of ignored. So an example is, if we look here, the parameter is 4. So 0 would be disabled. 1, 2, 3 would be for those options. So 4 is for a hidden option. This one is 3. So 0 is disabled. 1, 2, and then 3 is for the hidden option. Okay, here's an example of a bomb bag selection, which will show this within the game in a second. But just to go over what I was talking about with the event node param kind of being ignored. In this case, we're selecting between 3 different bomb bags. So you have results 0, 1, and 2. But pressing B gives you the hidden option. So you would expect the event param here to be 4 because 0 is disabled, and then 1, 2, 3 for these ones, and then 4 for the hidden option. However, the event param is actually 3, but specifically for bomb bag selections, which is event 1D. The event param appears to not matter. Maybe it would matter if it's 0, but like whether it's 3 or 4 or 2, I don't think it matters. So it's kind of inconsistent, but that's kind of what I was talking about. But that's not something that actually super matters. Okay, but let's quickly talk about event 1D. So this is event 029. So it's almost identical to event D, which is event 13, except it sets the message flows field 046 to 2 instead of 1, which we've already looked at. It's used for when you're asked from which bomb bag would you like to sell bombs, or into which bomb bag would you like to place bombs you're buying. Uses a 3-node structure, which is the event node with event index 1D, then a message node, which has a stupid number of tags in it, and then a branch node, which branches based on your selection. So if we look here, here's event 1D. The event params don't actually matter. Which bag should they go in? So what's going on here is that this is orange, this is white, right? And then this 2D31. I think this says something like bomb bag 1, bomb bag 2, something. And then these ones are, there's just a bunch of tags here. And these have to do with, so you see like 3, 1, 2, 3. These have to do with the bomb bags being rendered. Anyway, it's very confusing. And it's not something that we are probably going to make changes on. So I haven't spent the time to like research exactly what each of these tags mean. If we were ever messing with this more, then we can kind of do the research then, but it's not something I wanted to delay things on. But let's see. 3-node structure shows up in BMGs 2, 4, 5, and 8. Bomb flows are very complicated. We're probably not going to make any changes. Doing a deep dive is not the priority, so we'll leave it there. Yeah, so 1D, it has to do with bomb bag stuff. Show demo video in the City in the Sky shop. 54C for 3 bomb bags, and 54C. This is exactly what we're looking at, but let me go ahead and pull that up in the game so we can see what I'm talking about here. Okay, here we are in the game. So this is which bag should they go in, and then I have 3 bomb bags right now. One with 6 bombs, 21, and 30. But you can see there's the text box at the bottom of the screen, and there's no options on the right side. So this is what a bomb bag selection looks like. If we look back at the, this view here, then you can see that which bag should they go in. This is kind of where we are. And then based on the result, different event nodes. And then, won't fit in your bag, blah, blah, blah. There's also a version of this for 2 bomb bags, which let me show that. Okay, so here's the 2 bomb bag version. So yeah, there's a 2 version and a 3 version. And if there's only one, then I don't think it asks you, which is kind of how all the menus work. But yeah, there's how the bomb bags look. Okay, so that's basically the end of everything. Let's talk about next steps. So yeah, I need to finish a few remaining dev items, finalize the menu and required dungeons text for every language. I have to go through and clean a bunch of code. I have to make sure, like, get this stuff working on PAL and JP and make sure that works, which hopefully is not a huge deal, but and then need to create PRs for the generator and the randomizer, and I guess the libtp as well. I think I needed a couple of changes in there, or additions. And then as far as future steps, so this is stuff that's will come from this effort, but it's a little further out. So custom shop prices, as was shown, that will require logic work on the generator side, but once the logic's, like, we can handle that properly, then implementing it should be very quick. Also, custom Giovanni thresholds. I didn't show it here, but the whole, like, talking to Giovanni message flow stuff shows, like, we can find that in Zello for Castletown. And so we should be able to kind of work with that in order to set custom thresholds. So instead of just 20 and 60, we should be able to adjust those to be, if you wanted something like, I don't know, 10 and 25 or something, just as an example. Also, Uku, those conversations are handled within message flows as well. So there's a good chance that this message flow work, at the very least, should be able to kind of facilitate working on Uku improvements, just because now we have making adjustments to these message flows as like a tool in our pocket kind of thing. So yeah, there's that one. Some other stuff to do in the future, moving over custom text written in the CPP to come from the generator as well. I think I touched on that a lot earlier in it, but we'll probably end up doing that piece by piece in the future. Separate PR for starting hits on Midna. Yeah, so I showed how Midna can say your required dungeons, and then I showed some example hints on Midna, it was basically just the hints taken from the Ordon sign. But in terms of, like, actually placing starting hints on Midna, to where you, like, making adjustments to the hint distribution files and that kind of stuff, that's not going to be part of the initial PR, because that kind of messing with the hints code is a bit of an ordeal. It's like its own thing. And so mixing that with the more general system kind of code that's in these PRs would not make a lot of sense. So anyway, that part will be in its own PR in the future. Oh yeah, and then need to get the BMG viewer website, which is this thing. Need to get that to where other people can use it. So that's something, I don't know, that one might be a little more distant. The really distant ones are like Giovanni and Uku, as in, like, not any time within the next few months probably. And finally, I wanted to give some special thanks. So the first is to Lunar, which couldn't decide if I wanted to write Lunar Soap. I just say Lunar. I apologize. I've written it both ways now, so that's the option select. But anyway, Lunar got me started on this BMG stuff, because yeah, he provided me some stuff he had worked on, and I kind of had no clue going on. And so the initial work he had provided is kind of what led to me having a starting point to build out this BMG viewer site. So anyway, yeah, it was nice to have, like, research to go off of. And then, of course, working with Lunar has been very smooth for multiple years at this point. So yeah, thanks for being great to work with. And then I'd also like to give thanks to the TP decomp team, or whoever's working on that. As you have seen throughout the presentation, I've referenced the decomp extensively, and it's made working with this like way easier. I probably would have had to end up doing, like, if the decomp wasn't done, I probably would have been basically doing the decomp on my own, which would have taken forever. Yeah, I was super impressed by how much had actually been done. Yeah, pretty much almost any file I wanted to look into, there was actually quite a lot of it done already. So that's been, I guess that's been going well. This was like the first rando effort where I had really referenced the decomp. I've used Ghidra plenty in the past, but and just I continue to use Ghidra, but yeah, this was the first thing where I've really worked with the decomp work. So it's been yeah, super helpful, and I'm sure it'll continue to be really helpful in for future efforts. And with that, we have finally made it to the end. 102 slides. Yep. Okay. So no idea how long this video is going to be, but it's probably going to be pretty long. So looking forward to going and trimming everything. Yeah, we've already talked about what's coming up next. It'll probably be a handful of weeks before the PR and like everything's finally resolved for all this stuff, but as you've seen, hopefully it should open us up for quite a lot of good features. And then the BMG view is obviously pretty useful. So, but yeah, thanks to anyone who made it to the end. Hopefully learned a few things. I know I definitely have from working through this stuff, but anyway, that'll be the end of the video. So until I have something else to talk about for this long, but I'll see you then.